So, to the first lecture that we had in CAR by my Professor Dr. Brechna Jamil was data analysis with artificial intelligence. It was a very insightful lecture, and I'm going to read out it. So, the data deluge 2.5 quintillion bytes of data every day. The challenge is no longer collecting data, it is the challenge is making sense of it. And in the ocean of data, AI is most powerful lighthouse and navigational tool. So she pointed out that there are two pillars of data. So type of data analysis as was told qualitative versus quantitative. Quantitative is numbers. AI is collaborator and never a replacement. Quantitative data analysis. Descriptive statistics purpose for frequencies, cross-sectional descriptive, the prevalence studies. Central tendency, mean, median, mode. Dispersion, range, mean deviation, variance, standard deviation. Normality of data, skewed or normal, is shown in quantitative data analysis, descriptive statistics. Inferential statistics are for hypothesis testing, whether correlational or interventional studies. Parametric correlations, test of significance. Non-parametric are association, correlation, and test of significance. Factor analysis with SPSS or AMOS. Regression analysis with SAS or SPSS, and meta-analysis with STATA. These are different softwares. Steps in quantitative data collection and analysis. Okay, there are different tools: ChatGPT, Julius AI, Ask CSV, DeepSheet, Splash AI, Excel Copilot, 365 Microsoft, Power BI Copilot, Google Sheets with Gemini, JS AI or SPSS Syntax Assist, Stata GPT slash R Assistant is experimental tool. ChatGPT. Description is that upload CSV or SPSS file and it will perform descriptive or inferential statistics, write APA style interpretation, and makes graphs. Julius AI is a web app for instant statistical analysis. It executes correlations, regression, and visualization with no coding. Ask CSV is browser-based AI, answers up to 5 queries a day are uploaded CSV, ideal for crosstabs or summaries. Ask CSV. DeepSheet is AI spreadsheet interpreter. It handles Excel or CSV, unlimited queries, scan, plot, and interpret results. DeepSheet is free. Splash AI is web app for numeric plus visual interpretation. It accepts CSV, Excel, produces figures and written interpretation. Excel Copilot Microsoft 365 is a built-in generative assistant. It explains data, detects trends or outliers, and build pivot or tables or charts. Power BI Copilot is a conversational BI analytic. It is natural language query, show trend and test score by year. Like the command can be given to Power BI Copilot. Google Sheets and Gemini are AI assistants in Google Workspace. They give questions and answers over data. Automatic charts and summaries are also there. JASP AI or SPSS Syntax Assist is AI guided stats platform. It explains output, suggests suitable tests, and generates text. While StatHa, GPT or R Assistant experimental, and it generates add-on and converts natural language requests to statistical code, factor, or regression. So we were given insights into AI tools for quantitative data analysis. Excel, Ask CSV, and DeepSheet. Quantitative data analysis and interpretation using artificial intelligence of AskCSV.com. Developing a CSV file from SPSS or Excel, but only 5 questions per day were answered in Ask CSV in the free version. In quantitative data analysis and interpretation using Splash AI at aisplash.me/ it interpret other files in addition to CSV. There are 5 free credits and it can develop figures as well. Deepsheet.dylancastello.co interpret an Excel file in addition to CSV. No question limit so far in the free version of DeepSheet, and it can develop figures. Unfortunately, when you enter only DeepSheet, you may come across so many fake websites, and you have to exactly enter this address given here. Otherwise, you will land somewhere in the deep sheet. So, how should GPT analyze quantitative data? ChatGPT has a three-step process. It receives your user prompt, user input data analysis request. Second, it processes with Python, which execute analysis using the libraries of Python. And third is it presents results through displaying statistical summaries and visualizations. So sample output is statistical summary, mean, median, standard deviation displayed in table, data visualization is scatter plot showing correlation between variables, and interpretation, brief explanation of results and its significance. Protecting privacy in AI driven data is very crucial, and you have to anonymize your data through removing identifiers with deleting name, addresses from data sets before putting them subjecting them before analysis. Use pseudonyms, replace identifiable information with coded identifiers, and aggregate data, that is, group data to obscure individual identities. So, ChatGPT versus Julius AI for quantitative analysis, comparing two AI platforms for data analysis. Programming language of ChatGPT is Python for analysis, while Julius AI chooses between Python and R language. AI models ChatGPT best model is 5.0 and Julius AI options GPT 5, Gemini, Claude 3 and others. So about the practice data, this is the downloading data and generating data, cases, variables and values, cases, individual units of analysis and data set, for example, P1, P2, P3, and then variables are the characteristics or concepts made for each case. Continuous variables are age information, satisfaction information, stigma perception, willingness to disclose. Categorical variables are gender, employment status, and diagnosis. Values are assigned to actual data, each variable for each case. For the variable age, some values are 21, 30, 45, and for gender, values include male, female, and other, and for variable information satisfaction, values range from 1 to 5. So, quantitative data analysis and Excel handout has been shown. You can see that what are the variables being tested in this Excel handout. Descriptive statistics describing cases, variables, values, and relationships between them. About continuous variable age, mean age in the data set is 41.1 year as in the above. Histogram age distribution is shown continuous variable age with mean 41.1. It has the frequency of different age ranges. You can see in this histogram. It is categorical variable genders, majority were female, number is 50. Because of the other gender, females have crossed the male population and there are 50 females. Gender distribution of the participants. Employment status categorical variable and you can see the distribution in pie chart. So if you give the prompt, can you show me the values for employment status frequency? In addition, create a pie chart to show the distribution and it did this and it showed so beautifully. Qualitative data analysis technique is content analysis with word frequencies, quantification, thematic analysis most commonly used, framework analysis, theoretical models, narrative analysis, and stories, phenomenal analysis, phenomena, discourse analysis for content, and thematic analysis techniques. ChatGPT upload transcript or interviews for auto coding and thematic clustering. Key features are that it generates initial code, summaries, codes by theme, and supports Brown and Clark framework. Claude 3.5 handles long transcripts and documents, context-aware coding, narrative summaries, and concept mapping. Artifacts should be looked for in Claude 3.5. And Vivo AI Assistant is a built-in Lumivero in Vivo AI-driven auto-coding, thematic clustering, word clouds, and sentiment tagging. For Atlas.ti AI coding or intentional AI, classic CAD CAS with AI plugins, autocodes larger corpora, suggest emerging themes, extract sentiments and codes. Max 2D AI Assist is the next generation CACDAS with Gen AI integration, like chatting with your data, generate summaries and codebook suggestions. Dovetail is a web-based qualitative platform. It auto-transcripts with theme and sentiment tagging, AI summary, and dashboards. Notably is research synthesis workspace. It auto-highlights sentiment analysis, cross-study platform, pattern detection. And QDA Minor plus WordStat Pro Alice is a text mining suite. It combines qualitative, quantitative text analysis with dictionary and topic extraction. Transcription plugins, YouTube Summary AI, Otter AI, WhisperX generate transcripts for qualitative input, auto segment speaker turns ready for ChatGPT and Vivo upload directly. And in the last, Perplexity AI or Binge Copilot is good for conceptual framework or literature, mapping and retrieves and summarizes relevant qualitative literature. Qualitative data analysis tools, text, transcripts, and reflections. So here is an example of thematic data analysis. The question is compare this ambulatory care rotation to other clinical rotations you have taken. What special contribution, if any, did it make in preparing you to become a physician? For example, knowledge, clinical competence, career development. Example of thematic data analysis transcription. The independence allowed me to gain more confidence in my clinical skills. The hurried pace helped me to become more efficient, gave me a good start at learning to prioritize in a clinic visit of a finite time period. Outpatient management of disease is not really addressed in any other rotation. Also, the sheer number of patients seen really allows you to hone your H&P skills and gain confidence in patient interaction. This is also the only rotation where you see the administrative side of medicine. So these are the two different responses, and then the thematic data analysis is applied. And in initial coding, independence, gain more confidence in my clinical skills, hurried pace, learning to prioritize in a clinical visit of a finite time period is initial coding in the first statement. Outpatient management of disease is not really addressed in any other rotation. Sheer number of patients in hone your H&P skill, gain confidence in patient interaction, and administrative side of medicine are initial coding in this paragraph. So the classification is then done, and in curriculum theme, outpatient management of disease not addressed in any other rotation. Educational experience, independent helping independence help increase confidence in clinical skills. Quick pace helps to increase efficiency. SA administrative side of medicine. So these are coded by EI, EE, and EA. Outcomes, gain confidence in clinical skills, CC. Gain confidence in patient interaction, CI. Learned administrative side medicine, OLA. OSE, learn to become more efficient. OSPR, learn to prioritize in a clinic visit. OSPX, improved physical examination skills. Classification 2, rotation attributes contributing to student learning. AP, quick pace. AL, independent work. Student knowledge, KA, clinical administration. KO, outpatient management. Student skill, SH, hone skills in H&P. SP, learning to prioritize issues in clinic visits. Student attitudes, AC, increased confidence in patient interaction. Utilization of AI and qualitative data analysis software or manual analysis, Otter AI, ChatGPT, and Atlas.di for qualitative data analysis. And steps in qualitative data analysis can be uh, uh, accessed through interview or focus group discussion as on YouTube, ChatGPT, and Atlas.di. QDA exercise, YouTube transcripts are here. You can see there is a transcription of all the videos where you can access the transcripts. YouTube can give you the transcript here in this tab as shown, and then you can take your transcript and you can copy the transcript to MS Word for manual data analysis or to be imported to the software. Can also copy it to ChatGPT or Bing AI or Perplexity to use AI for qualitative data analysis, but not more than 3000 words. Google Chrome or Safari plugin for transcription is also there. YouTube and article summary powered by ChatGPT can be added to Chrome. You can see that it can help you qualitative data analysis with ChatGPT. Atlas.ti and NVIVO can help you qualitative data analysis, and these are the main tools for using AI. Another important topic, AI in research and education. So, what is artificial intelligence? It is basically a computer system for performing tasks that typically require human intelligence, problem solving, learning, decision making, and understanding natural language. Narrow or weak AI focuses on specific tasks. Chatbots, medical diagnosis tools are weak AI. While general or strong AI, the world has been ripped apart by generals. A hypothetical form of AI with human-like reasoning, creativity, and adaptability across domains. It doesn't exist yet, but is a research tool. For example, AI doctor, AI teacher, and AI generals. General AI. Generative AI. Recent advancement where AI creates new content, text, images, videos, codes used mostly by South Asians these days. Artificial intelligence types and examples. I am myself a South Asian, so don't worry. It was just to make it to memory. Okay. Artificial intelligence types and examples. Narrow AI, chatbots, Siri, Alexa, ChatGPT. Sorry, we wrote ClatGPT, but it is ChatGPT. General AI is the strong AI, which is hypothetical. Generative AI is ChatGPT, Claude, and Gemini. Narrow AI may be used in medical diagnosis, IBM, Watson Health. General AI may be used as AI teacher for all subjects, while generative AI may be used for DALL-E, Midjourney, Stable Diffusion Images, Code, GitHub, Copilot, and video avatars. Synthesia AI being increasingly used across Facebook these days. Spam filters are narrow AI, Gmail AI, and general AI, that is strong AI, is a fiction. Jarvis and Hall 9000 is general or strong AI. So AI may enhance efficiency, personalization, and innovation by application in writing, analysis, simulation, and teaching, and acts as a partner in learning and discovery. Why we want to use AI? We want automation of repetitive tasks, data-driven decision making, personalization and adaptive learning, speed and efficiency, innovation and CEW capabilities. Education. AI tutoring systems provide 24/7 support, so they don't sleep anytime. Faculty use AI to prepare content and grade essays. 92% UK students use AI for assessment. Business. 78% companies globally use AI in at least one function. Generative AI adoption has reached 71% in firms. AI assist in customer service and decision support. Healthcare. AI reads medical images with high accuracy. Debatable, but there is increasing intrusion. Hospitals leverage AI for patient admissions, forecasts, AI aids in drug discovery and patient support. Society and governance. AI is used for traffic management and fraud detection. AI models monitor climate and optimize energy grids. AI tools empower those with disabilities. That is a useful thing. AI for research. Literature search and review, illicit.org, Research Rabbit, Connected Papers, Cite AI, Semantic Scholar, automates literature review, maps related study, analyze citations. Example used in research extract study outcomes on AI in medical education from 100 plus articles. So for reference and knowledge management, Zotero plus Zotero GPT, EndNote, Click, Scholar C manages references, summarize and organize readings. Scholarly convert a 20-page article into a summary flashcard. For data analysis, when you are doing quantitative, IBM SPSS modeler with AI features, Rapid Miner, Orange 3, WEKA are used for predictive modeling, machine learning based data analysis, and building a logistic regression model to predict student performance as an example of this work done by these for data analysis in quantitative research. For qualitative data analysis, in vivo AI coding assistant, Atlas.ti with AI features, ChatGPT assisted coding will help with coding, clustering, and theme development. And as an example, AI suggests initial codes for 30 interviews transcripts. Writing and drafting. Writeful, Grammarly, Go, Killboard, Trinka improves clarity, grammar, and academic phrasing, and write full checks manuscript. Summarization and knowledge extraction, Scholarly, ChatGPT, Claude Gemini condenses long text, extract key findings. ChatGPT generates a structured summary of 10 RCTs. Publishing and peer review, Turnitin AI detection, PubPeer AI, Elsevier Reviewer Finder, which ensures originality, detects anomalies, matches reviewers, and Turnitin flag sections with a high AI return probability. Visualization and concept mapping. Visualization and concept mapping is done by Connected Papers, VOS Viewer, AI clustering, and Dimensions.ai. They create citation networks, thematic maps, and VOS Viewer clusters keywords from 500 abstracts. That is a huge visualization and concept mapping. Research integrity and ethics, Turnitin, draft coach, image twin, Appear AI, they will detect plagiarism, image manipulation, data irregularities, image twins, spots duplicated microscopy images in a drafted paper. There are specific AI tools for education. So there are some of them, we will discuss them one by one. If you want teaching and content creation, ChatGPT, Copilot in Microsoft and Google Gemini, they will generate lesson plans, case studies, and lecture notes. And a teacher can ask ChatGPT to create 3 patient cases for PBL in previous module. Interactive learning and tutoring. Khanmigo, Khan Academy AI. Duolingo Max and Coursera AI Tutor. They can provide adaptive explanation and conversational practice. Hanigo explained photosynthesis at different difficulty levels. Student engagement and quizzes by Quizzes AI, Kahoot AI, Quizmaker, and Socratic Google. They create quizzes, interactive games, and support inquiry-based learning. Quizzes AI auto-generate MCQs from any subject. Assessment and feedback. GradeScope AI, Turnitin, Draft Coach, ETS, E-Rater, and Criterion can do automated grading, plagiarism check, and writing feedback. GradeScope grades assignment with AI-assisted rubric. Personalized learning by Century Tech, Squirrel AI, and Newton. Learners analytics, adaptive pathways, remediation suggestions, and example is Century Tech identifies a student struggling with algebra and assigns extra practice for that particular student. Writing and language support. Grammarly, Quillbot, and Writeful improve student essays, clarity, academic writing. And example is Writeful gives real-time feedback on students' reflection. Learning management and prediction. Moodle AI plugins, Canvas, Intelligence, Brightspace Insights predict dropout risk, tracks engagement, recommend resources. Moodle AI predicts which students are at risk of failing a module. Student support and chatbots. Ivy.ai, Admit Hub, Replica for mentoring support, AI chatbots for frequently asked questions, admissions, well-being support. Example is Ivy.ai answer 24/7 student question about course registration. Accessibility and inclusion. Otter AI, TurboScribe, Whisper AI, speech to text. Seeing AI provides transcripts, captions, text to speech. Whisper AI will transcribe lectures for hearing impaired learners. So the global usage of AI tools is growing. ChatGPT 60% market share. Overall chatbot adoption, Claude or Socratic, Board, Bard, Gemini, ChatGPT and Copilot, DeepSeek. ChatGPT has about 400 million weekly users. So this is hundreds of million users. So AI in education and research, 66% ChatGPT use. Two AI tools are used by students on average. Literature search, and review, and writing. And they use AI tools like elite schools, they use them. AI is used in healthcare and health education and K-12 teaching and higher education. Generative AI chatbot market share. ChatGPT clearly outsmarts Copilot and Google Gemini Bard and active users at the moment. Meta AI followed by ChatGPT, Gemini, Copilot, and Claude. App download share ChatGPT followed by DeepSeek, Gemini, and Copilot. ChatGPT has had a fastest growth, followed by Gemini, Claude, and Meta AI. So AI chatbots. The topper is ChatGPT, followed by Gemini, DeepSeek, and Perplexity and Claude are the shareholders in equal amounts. OpenAI says it has proof its tools are making workers more productive. So it also has great role in learning and upskilling, writing and communication, programming, data science and maths, creative ideation, business analytics, and even translation. Bismillahirrahmanirrahim. It is Sunday and early morning, 6 a.m., and we are going to discuss a very important, extremely useful AI prompt engineering. What is prompting? Process of giving instructions, questions, or cues to an AI model like ChatGPT, Claude, or Gemini to guide its response. That is called a prompt. It is basically like a conversation starter or command which tells AI what role to take, what task to perform, and how the output should look. The better and clearer the prompt, the more useful and accurate the AI's answers will be. So the basic thing is asking the right way in prompting, as it is said that if you want something, ask for it. It is as simple as that. But the right way for asking is a skill, crafting instructions that help AI give meaningful, relevant, and structured answers, and no bluffing. So we use which frameworks and why they matter. Clinical Reasoning Framework SOAP SBAR to structure patient care, prompt framework structure AI interactions for better outcomes. The cognitive load theory correction. Unstructured prompts will lead to high cognitive load and poor AI performance. Structured prompts will reduce ambiguity and give precise, relevant outputs. Health profession education, we need AI that maintains clinical accuracy, respects cultural contexts, follow ethical guidelines, and adapt to diverse learning needs. What are the key elements of a prompt? First is instruction. What you want the AI to do. For example, you want it to summarize this article in 100 words. Second is context, background or detail the AI needs. Example, you are an expert in medical education. Third is format, how the answer should be structured. Provide the result in table with columns, theme, code, and quote, and constraints. Limit the word count, style, or audience. Explain in simple terms for first year medical students. There is a joke that someone gave that explain it as if you are explaining it to a donkey. And that was very funny. But the constraint has to be put whatever one's like the constraint. What are the prompts frameworks? Prompt frameworks, the complete toolkit when you need comprehensive, detailed output gives structural frameworks. For example, race, role, action, context, expectation. Race, you are a, define the role. Action, what has to be done. For context, and I expect, expectation. You fill in the blanks of these greenish bars. Example is you are clinical skill instructor. Action design a 3 station OSCE on cardiovascular examination for context third year medical students in resource limited setting. Expectation I expect clear rubrics, timing, and equipment lists. Best for curriculum design, assessment creation, and role play scenarios. Other is trace, task, request, action, context, example. This trace template is task that request by action within context similar to example. So write a literature review section that synthesizes telehealth effectiveness by analyzing 5 recent studies within a rural health care context similar to systematic review methodology. It is best for academic writing, research synthesis, manuscript development. Crisp, clarity, relevance, iteration, structure, precision, ethics template is best for quality assurance, peer review, and content validation. Crisp, clarity, relevance, iteration, structure, precision, ethics template is example. Evaluate this dash content for clarity, relevance, structure, precision, and ethics. Suggest specific improvements. Example. Evaluate this patient case study for clarity of presentation, clinical relevance, logical structure, diagnostic precision, and ethical consideration. Suggest improvements. And, quality assurance, peer reviews, and content validation is achieved through this crisp format. The CoStar framework is context, objective, style, tone, audience, and response. The CoStar framework context provide background information to help AI understand the specific scenario. Objective clearly define the task to direct the AI's focus. Style specify the desired writing style to align the AI's response. Tone set the tone to ensure the response resonates with the required sentiment. Audience identify the intended audience so the AI can tailor the response accordingly. Response define the format of the response to get structured, useful output. So, here is an example. I work in a non-profit organization. This is a context, and I have been asked to write an electronic direct mailer informing people about climate change objective. Write this in the style of popular lifestyle publication style, keeping the tone informal and friendly. Tone. This will be read by audience residing in Pakistan. Audience. I need this to be about 350 words long, broken up into paragraphs of 100 words each, and with a call to action to sign up for the newsletter response. Minimalist frameworks for quick, effective interactions are one of the example is tag, task, action, goal template. Tag task, action, goal. Task by action to achieve a goal. It is best for quick summaries, checklists, and brief contents. And pro example is summarize key competencies for rural family medicine by extracting main points to create a study guide. RTF or role task format template. Role task format template as a role task in format. It is for professional correspondence and formal documents. As a program director, write a recommendation letter for a resident in formal academic format. APE Action Purpose Execution Template. APE Action Purpose Execution Template is best for patient education material and quick reference guide. For example, is create visual infographics for patient education about diabetes management through simple icons and bullet points. Reflective frameworks for professional development and critical analysis are like CARE, context action result. CARE is basically best for teaching, portfolios, CPD documentation, and reflective practice. CARE, for example, in a challenging bedside teaching movement, I use the 1 minute preceptor model resulting in improved student confidence. For instance, when teaching heart murmurs assessment. So it is care, context, action, result. Example. Another one is STAR stimulation, task, action, result template that is best for leadership development, problem solving, and documentation. Star format, for example, is situation, low student engagement in online lectures, task, increase participation, action, implement interactive polls and breakout rooms, result 80% participation increase. Spear, situation, problem exploration, action, result template. Spear is best for critical incidents, complex problem solving. In our simulation lab, equipment failure emerged. I explored backup options and alternative scenarios, implemented low fidelity alternatives, achieving full session completion. Narrative frameworks for storytelling and persuasive content. BAB, before after bridge template. BAB is for change management and implementation stories. Initial state before, desired state after, bridge transition process. For example, before traditional lectures with passive learning, after interactive case-based sessions with active participation, bridge gradual implementation of problem-based learning methodologies, BAB, before after, bridge template for change management and implementation stories. There is another format, AIDA, attention, interest, desire, action template, attention, hook, interest, relevance, desire, benefit, action, next step. For example, attention, medical errors cause lives, interest, simulation training reduces by 60%. Desire. Your students deserve the best preparation. Action. Join our simulation workshop series. It is best for grant proposals, conference presentation, and market. We have another format: problem, agitation, solution, template, problem, issue, agitation, consequences, and solution, intervention form. It is used best for public and for policy advocacy, needs assessment, and problem identification. So PAS, problem, agitation, solution. Example is problem is that medical students lack cultural competency training. Agitation, this leads to health disparities and poor patient outcomes. Solution, integrate community-based learning experiences. Advanced techniques for complex reasoning and multi-step processes. Chain of thought code template. Chain of thought is think step by step, step one, two, three, step three, and therefore conclusion. This is a chain of thought. Chain of thought is used for complex planning, systematic design, and logical reasoning. An example is that design a clinical reasoning curriculum step by step. Number one, identify learning objectives. Two, map to competency frameworks. Three, select appropriate cases. Four, create assessment rubrics, therefore ensuring systematic skill development. Now you can see you can give a step by step chain of thought template, and the complex planning and systematic design and logical reasoning will follow. Generated knowledge prompting template is first generate background and knowledge, then use this to main task. What it is used for? Generated knowledge prompting is used best for knowledge synthesis and comprehensive planning. For example, first generate a list of key cultural considerations in mental health care, then use this to design a cultural competency training module. Another template, React Reasoning Acting template, best for evidence-based practice, iterative improvement. Reasoning students struggle with clinical decision making, action, implement case-based learning, observation, improved critical thinking scores, reflection, active learning enhances clinical reasoning, react reasoning and acting. You can see the template: reasoning, analysis, action, implementation, observation, result, and reflection, learning. So smart framework selection is requires a quick decision, and when your primary goal is quick information, you go tag RTF and APE. When you want complex planning, you go for race, trace, and code. When you want professional growth, go for care, star, and spear. When you want persuasive content, you go for AIDA, PAS, and DAP. You want for quality assurance, you go for CRISPE. So this is the summary of the prompts that you get to go with depending upon what is your primary goal. There are some advanced prompting strategies like prompt chaining, link multiple frameworks for complex tasks. Like step 1, use RACE to define role and context. Step 2, apply CORT for systematic reasoning. Step 3, implement CRISP for quality check. So this is linking multiple framework for complex tasks, and it is so beautiful. The essential five: master these first. Race, role-based structured task, tag, quick simple requests, care, professional reflection, caught complex reasoning, and crisp or quality evaluation. The Fantastic Five or Essential Five or Master Five. The five framework families review. Structural, raise, trace, crisp for complex detailed tasks. Minimalist, tag, RTF, APE for quick efficient requests. Reflective care starts peer professional development. Narrative ADA pass back for storytelling and persuasion. Advanced court generated knowledge react and complex reasoning for these these are used. There are some emergency copy paste ready prompts like quick summary summarize topic in five key points for audience. Role assignment you are a role action for context. Step by step explain step by step how to test task. Quality check evaluate this content for clarity, accuracy, and ethics. These are the emergency prompt, copy paste ready prompts. Prompt crafting in action. Three real examples. Example 1 The curriculum designer. Challenge design a cardiology rotation for resident. Poor prompt. Problem too vague, no context, no outcome specified. This is not a good. No excellent prompt would be like this. Race and court. You are experienced cardiology educator and curriculum designer. Create a 4 week cardiology rotation for internal medicine trainees in a tertiary care hospital setting. Think step by step. First, identify core cardiology competencies for internal medicine. Second, map competencies to weekly learning objectives. Third, design clinical experience and assessment. Fourth, create a balanced schedule. I expect weekly learning objectives aligned with ACGME competencies, mix of inpatient, outpatient, and procedural experiences, assessment methods and schedules, resource requirement and constraint. Context 50-bed cardiac unit with two attending cardiologists, cath lab access, residents rotate in pairs, 80 hours work week limits. Why this works? It gives clear role, specific context, step-by-step reasoning, detailed expectation, and realistic constraints. There are no out-of-the-world constraints in this. Example 2 The assessment creator. Challenge create practical exam without resource intensive OSCEs. Poor prompt. Create an exam for clinical skills. It will lead no result. However, an excellent prompt will be trace and crisp. Trace task create innovative practical assessment for physical examination skill. Request design resource efficient alternative to traditional OSCE. Action develop hybrid assessment with virtual patient and peer evaluation. Context 120 third year medical students, limited faculty time, assess cardiovascular, respiratory, and abdominal examination skill. Example similar to virtual ASCII models but with inpatient components. This is the trace prompt, and the CRISP is for evaluating your design. Clarity assessment format clear to student and faculty? Question mark. Relevance assess intended clinical skills? Question mark. Structure logically organized? Question mark. Precision specific measurable criteria? Question mark. Ethics fair and accommodating to diverse learners? Question mark. Include rubrics, timing and implementation steps. Why this works? Complete task definition, built-in quality evaluation, and specific deliverables. Example 3 The Reflective Educator Challenge. Learn from a difficult teaching moment. Proven prompt. Excellent prompt is care plus pair. Care help We reflect using SPARE framework on this teaching challenge. Situation during bedside round. A student challenged by antibiotic choice in front of the patient problem. Appropriate academic question, inappropriate timing or setting potentially undermine patient confidence. Exploration how to encourage critical thinking while maintaining professional boundaries and patient trust. Action. What specific strategies should I use next time? Question mark. Result. What outcome indicates successful handling? Care. Context. Contributing factors to the situation. Action. What I will do differently next time. Result. Expected positive outcomes. Examples. Specific scenarios for future similar situations include consideration for patient care, educational value, and professional development. Why this works? Use a complementary framework, specific situation, requests, actionable outcomes, context specific recommendations. In health profession education, when you are planning curriculum, you go for race and card because role clarity and step by step logic. For research writing, trace and crisp because they are comprehensive, context and quality driven. Teaching reflection, care and spare, experience focused and deep analysis. Student assessment, star and crisp, structured evaluation with quality assurance. Grant writing, AIDA plus PAS, persuasive structure with problem focus. Policy development, PAS plus CORD, problem identification with logical reasoning. There are other advanced crafting of prompt techniques. Technique one is the layered approach. Start with basic framework, then add layers. Basic framework is the race, role, action, context, and expectation. Cultural layer, consider diverse population. Plus, ethical layer, ensure patient privacy and context. Plus, practical layer, account for resource limitation. Plus, evidence layer based on current best practices. So, the layer adding technique. The second technique is constraint challenge, a realistic limitation for practical solution. Designed with these constraints, maximum 2 hour faculty time. Budget rupees 500. Space one classroom and 40 student and technology laptops only. Technique 3 framework combinations. So you can go for prompt quality checklist before submitting by prompt. Verify the 5 essential elements. Role clear who AI should be. Context specific situation and constraint. Outcome defined success criteria. Format request output structure. Ethics, privacy, and bias consideration. Quality assessment. Rate 1 to 5. Clarity is request specific and unambiguous. Context is the background complete and relevant. Actionability are outputs implementable. Completeness are all requirements included. Ethics are considerations addressed. So the total score of 25. And 20 to 25 it is excellent, ready to use. A 15 to 19 good with minor refinement. Periods 10 to 14 needs improvement and below 10 needs start over for prompt quality checklist scoring. You are prompted template copy and customize for curriculum development, for assessment criterion, for professional reflection, for innovation projects, and for common prompting mistakes to avoid. The generic request trap, the context-free problem, the one-size-fits-all issues. Don't use same framework for every task. Do mesh framework to task complexity and purpose. The constraint blind mistake. Don't ignore practical limitations and do include realistic resources, time and space constraint. Pro tips for medical education prompting is that always include learner level year experience background, learning objective, clear, measurable outcome, context, strength, resources, time, cultural factor, competency alignment, WAF, BPM, DC, SEJME, LCME are relevant standards, ethical considerations, privacy bias, cultural sensitivity, framework selection strategies, simple task, minimalist frameworks, tag, RTF AP, complex planning, structural frameworks, race trace, professional growth, reflective frameworks, care stars, peer, innovation or change narrative frameworks, AIDA, PAS, and BAP have multiple step problems, advanced technique, got and react. So success formula is excellent prompt is equal to right framework with a rich context, with clear expectation and ethical awareness. Quick reference card, framework selection guide, quick task, tag RTF APE, complex projects, race, trace, caught, reflection, care stars, spear, persuasion, AIDA, PAS, and BAP. Quality check with Chris. Post-lecture checklist. Review the three detailed examples. Identify your top three for frameworks for common tasks. Complete the quality checklist practice. Ethical guidelines are frameworks using AI. UNESCO recommendations on ethics of artificial intelligence 2021, the first ever global standard for AI ethics, formally adopted by all member states, aims to ensure AI serves humanity, society, and the environment responsibly in UNESCO 2021 recommendations. Then there is guidance for generative AI in education and research updated in April 2025. This guidance offers a human-centered approach to implementing generative AI, Gen AI, in learning and research environment. HEC has its own as a framework for ethical use of generative AI, and this policy lays out how higher education institutions in Pakistan can responsibly use Gen AI tools like GPT-3, ChatGPT for teaching, learning, research, and administration. HEC policy balances innovation with ethical standards, focusing on transparency, concept, fairness, data privacy, academic integrity, and explainability. Transparency, disclose AI involvement, fairness, mitigate bias, accountability, humans remain responsible, data privacy, protect sensitive information, academic integrity, avoid plagiarism, ensure originality. So addressing misconceptions. AI will replace teachers, while reality is AI is a tool. It will assist educators, it will help the teachers, and it will never replace them. Key takeaways. Key takeaways are that AI is the best thing to use in proper frameworks with a better prompting and ethical responsibility. So we will discuss ethical concerns in AI. Many of us use AI tool in our daily life, but the main thing is that ethics should be considered. AI is now scheduled in teaching, assessment, and research. AI model influence decision affecting learners. Rising concerns of unfair grading, plagiarism, and data misuse. UNESCO ethics must guide every stage of AI deployment. HEC in Pakistan, AI use must ensure academic integrity, transparency, and student safety. So, How can educational institutions leverage AI responsibility while ensuring fairness, transparency, accountability, and human dignity? UNESCO framework, AI in education, human rights and dignity, inclusiveness and equity, fairness and non-discrimination, transparency and explainability, responsibility and accountability, data privacy and protection, human oversight and control, and environmental and societal well-being. So, proportionality and do no harm. Use of AI systems must not go beyond what is necessary to achieve a legitimate aim. Risk assessment should be used to prevent harms which may result from such uses. Safety and security. Unwanted harms, safety risks, as well as vulnerabilities to attack security risks should be avoided and addressed by AI actors. Right to privacy and data protection. Privacy must be protected and promoted throughout the AI life cycle. Adequate data protection frameworks should be established. Multi-stakeholder and adaptive governance and collaboration. International law and national sovereignty must be respected in the use of data. Additionally, participation of diverse stakeholders is necessary for inclusive approach in AI governance. Responsibility and accountability. All AI systems should be auditable and traceable. There should be oversight, impact assessment, audit, and due diligence mechanisms in place to avoid conflicts with human rights, norms, and threats to environmental well-beings. Transparency and explainability. The ethical deployment of our AI system depend upon their transparency and explainability T and E. The level of T and E should be appropriate to the context, as there may be tensions between T and E and other principles such as privacy, safety, and security. Human oversight and determination. Member states should ensure that AI systems do not displace ultimate human responsibility and accountability. Sustainability. AI technologies should be assessed against their impact on sustainability, understood as a set of constantly evolving goals, including those set out in the UN Sustainable Development Goals. Awareness and literacy, public understanding of and data should be promoted through the open, accessible education, civilian engagement, digital skills, AI ethics training, media information and literacy, and fairness and non-discrimination. AI actors should promote social justice, fairness, and non-discrimination while taking an inclusive approach to ensure AI's benefits are accessible to all people. It is April 3rd and 2026, and today we are going to discuss the HEC AI policy. What does HEC of Pakistan say about AI? So the guidance is that AI must not replace learning. It may assist learning. You have to disclose use of AI in your assessment. It is mandatory. AI generated work cannot be submitted as original work. There is a strict stance on data fabrication. AI generated literature reviews without citation is not acceptable and should not be done. Universities must develop AI policies, plagiarism detection, and training. Ethical approval is required for AI use in research involving human data. So, what are the ethical domains in AI? Privacy and data protection, bias and fairness, transparency and explainability, academic integrity and misconduct, copywriting and equity and access, human AI collaboration and accountability and governance are main issues for ethical domains in AI. So, and they spot the ethical domain here. AI penalize students without with accents. This was a bias. Teacher upload exam questions into ChatGPT. That is the problem with privacy or integrity. Students submit AI generated thesis chapter. That is a misconduct. All students commonly use AI. They will use it for brainstorming or outlining ideas, getting explanation for difficult concepts, drafting emails or basic templates, language support by Grammarly Clarity or grammar and translation, generating practice question or quizzes, coding help or debugging with understanding. These can be helpful, but now let's look at where things go wrong. So, common types of misuse in generative AI. When students submit AI generated assignments or essays, use AI to solve exams, quizzes, or graded tasks, fabricated or AI invented citations, incorrect or misleading AI generated references, creating fake database datasets or manipulated data, uploading personal, confidential, or participant data into AI tools, blindly trusting incorrect or biased AI outputs, using AI to write literature reviews or thesis section, paraphrasing through AI to bypass plagiarism checks, generating false interview transcripts or qualitative data, AI enhanced manipulation of images, charts, or figures, letting AI complete group work or team deliverables, over dependence on AI for basic learning tasks, using AI to derive research gaps, problem statements, or framework, AI misuse in writing emails, reports, or reflective tasks, using AI to generate clinical or scientific explanation without verification, sharing exam items or confidential materials with AI platform, using AI as the primary source instead of reading original literature. So when you start, is the generative tool used? And if yes, is there declaration of AI generated tools? If yes, cite AI contributions. If yes, use them for academic purpose proposed in section 6. If yes, plagiarism check as per the prevalent HEC criteria. If yes, prevalent plagiarism understanding statement added. If yes, compliance with existing copyrights and IP laws. And if yes, final check by the supervisor as per HEC criteria. And if no, review project thesis or report and reassessment by the supervisor is recommended. Individual responsibility of student is action to be taken by a concerned committee. Ethical concern and bias and discrimination. So there can be biased data sets, biased learning analytics, AI grading disadvantages non-native English speakers. Gendered prompts result in stereotyping. Predictive analysis reinforcing inequalities. UNESCO principle is fairness and non-discrimination. So there are different ethical concerns regarding data privacy and security. Cloud-based AI storing student queries and personal data. Learning platforms tracking behavior without consent. Plagiarism checkers storing manuscripts. AI-powered proctoring flagged dark skin disability or headscarves. UNESCO principle is right to privacy, and HEC says that student data sharing must be consented and secure. Third ethical concerns is academic integrity and misuse. Examples of misuse are ghostwriting via ChatGPT, fabricated references, phantom citations, full essays written by AI without understanding. Students are bypassing cognitive efforts. HEC says that the undisclosed AI use is equal to academic misconduct. Fourth ethical concern is hallucination and misinformation. AI creates false citation, fake quotes, produce fabricated data tables. Students may report incorrect medical or scientific facts. Researchers risk invalid conclusion. A researcher submitted a manuscript with 20 AI-generated fake references and was subjected to rejection and investigation. Authorship and accountability. Can AI be an author? No. Plain no. AI lacks responsibility, cannot approve final manuscript. Journals disclose prompts, version, tools used, and UNESCO human accountability is not non-negotiable. Ethical concern number six, human replacement debate. Fear of losing teaching jobs, reliance on automated grading or chatbots, reduction of human empathy in education. AI should augment, not replace teachers. UNESCO ensure human oversight for this human replacement debate. Ethical concern 7 is equity and access. Paid tools create inequity. Students in rural low-income communities are left behind. There is a digital literacy gap. There is a risk widening achievement gap, and UNESCO is inclusive for all, and AI should be inclusive AI for all. HEC says promote equitable access across all Pakistani institutions for all students. What groups of students in Pakistan are most at risk of being left behind? Obviously, we all know the answer. Ethical concern 8 is intellectual property and copyright. AI trained on copyright textbooks or journals. There is risk of plagiarism, no ownership clarity on AI generated images and texts, preprint servers flooded with AI written submissions, transparency and explainability, black box algorithms, unclear logic, automated grading lacks rationale, adaptive learning tools make hidden decisions, and students may challenge grades due to lack of explainability. Can we trust AI generated grade without explanation? The answer is probably no. Research ethics. AI generated fake qualitative transcripts using AI to modify or fabricate datasets. Image manipulation using generative AI. Literature reviews fully AI generated violates each EC policy. Lack of documentation of AI steps. Poor reproducibility. There are some case studies. Case study one: a student used AI to generate entire interview transcripts for a qualitative study. It was noticed there were identical phrasing and realistic quotes, no metadata or audio files. Outcome was degree withheld with research misconduct inquiry. Wherein your research workflow could misuse happen, how will you prevent it? Case study 2 is AI based bias grading. A university used AI based grading for English writing. Students from minority language backgrounds consistently scored lower. When manually reviewed, many had been unfairly penalized. Should AI be used for grading at all? Under what safeguards? The human supervision, obviously, and fair chance for everyone. Third case study is a postgraduate student using ChatGPT to summarize 40 papers, but summaries included studies that did not exist, a wrong sample size, and misinterpreted findings. So the boundary between assistance and misconduct. Privacy breach in class. A teacher asks student to rewrite reflection and submit them to an AI tool. The data was stored on external servers, later on leaked. Students were not informed. So external AI tools should be checked before any use. We have overviewed the ethical AI framework. There is a mnemonic RAISE, RIAISE, RAISE, R for responsible use, A for attribution and transparency, I for integrity and honesty, S for safety, security and privacy, and E for equity and hallucinations. You should give one promise for today what you will do when you will use AI. The conclusion is AI offer immense opportunities. Ethical concerns must guide its integration. UNESCO and HEC framework provides structure, but human judgment remains central whenever you are using AI. Your role as a person is to use AI smartly, critically, ethically. So that is all. Thank you. During this session, curriculum innovation with AI. Oh, I'm so sorry for the bad screen visibility, but that is the content already organized and I can't change it. So, what is the use of AI? It creates personalized learning pathway tailored to individual student needs and abilities. It can streamline grading and assessment, keeping educators focused on impartial assessment and impactful education. Enhance student engagement in interactive and adaptive content that responds to learners' progress. Support diverse learning styles and paces through AI driven adaptive learning. fostering inclusivity, prioritize better academic outcomes by aligning teaching methods with student specific needs. So, how we unlock education with AI tools. Machine learning predicts student behavior and personalizes learning resources for tailored education. Natural language processing (NLP) enhances language learning and powers AI writing assistants to improve communication skills. AI chatbots provide instant answers and simplify administrative tasks, boosting student access to support services. Unlock curriculum excellence with free and freemium AI tools. Empower educators with AI-driven support for content creation, engagement, and classroom management. ChatGPT Freemium enhances content creation and simplifies complex topics to support student understanding. Quizlet creates flashcards, quizzes, and learning games to reinforce student knowledge and retention. Google Classroom streamlines classroom management through easy communication, assignment distribution, and grading. Canva for Education designs engaging posters and infographics to enhance presentation and learning material. Empower teamwork with collaborative AI tools. Harness battles, boost creativity, organize projects, and track progress in group activities. Padlets, interactive boards, visually stimulate idea sharing and brainstorming, making collaboration intuitive and engaging. It enhances teamwork by improving communication, fostering transparency, and supporting seamless project planning. Transforming education with AI integration. How AI powered tools revolutionize teaching and learning outcomes worldwide. Personalized learning experiences using AI driven platforms tailored to students' needs. Automate administrative tasks to increase efficiency and reduce educator workload. Facilitate interactive and immersive experiences through AI-enhanced tools. Demonstrate AI transformative potential to enhance both teaching models and student outcomes. Upcoming Overcoming key challenges in AI education. Privacy concerns over student data require strict safeguards to maintain trust and comply with regulators. Many institutions face a lack of adequate infrastructure, limiting AI's effective deployment and access. Over reliance on AI risks reducing vital human interaction, which is essential for holistic education. Addressing these challenges demand ethical planning and sustained support to ensure AI enhances and not replace teaching. Unlocking AI power in curriculum development. Adopt these practices to ensure sustainable AI adoption and maximize educational benefit. Invest in ongoing professional development to build Educator AI skills confidently. Combine AI tools with traditional teaching to enhance, not replace pedagogy. Personalize learning pathways to address diverse student needs effectively. Unlocking AI impact in education. AI transform curriculum development and classroom management by boosting personalization, efficiency, and student engagement. Educators should explore AI tools through thoughtfully balancing technology with effective pedagogy. Open question and answer sessions invite participants to ask questions, share experiences, and discuss practical implementation strategies. Unlock continuous growth with AI resources. Encourage your teachers or empower your teaching by exploring expert blogs, vibrant communities, and in-depth courses that drive innovation and insight. AI education blogs offer timely updates and expert perspectives to deepen understanding of AI's evolving role in education. Professional communities connect educators to peers and thought leaders for collaboration support and sharing best practices. Online courses provide structured learning paths to master AI concepts and apply innovative strategies in curriculum design. Suggested readings deliver deeper insight into AI trends and effective curriculum innovation methods to keep educators ahead. Efficient curriculum mapping, leveraging AI to optimize curriculum design and competencies alignment. Automated curriculum design, AI analyze educational content and align it with the learning objectives, meeting international standards and accreditation requirement. Mapping competencies to content. AI ensures course content aligns with key competencies such as clinical skills, medical ethics, and patient care, maintaining consistency across modules. Identifying gaps in curriculum. AI detects underrepresented areas like critical thinking or diagnostic reasoning and suggests additions to strengthen the curriculum. Data-driven curriculum evaluation, leveraging AI to analyze performance and enhance learning outcomes. Analyzing student performance data, AI can analyze data from assessment, quizzes, exams, and clinical evaluation to identify trends and areas where students are struggling. This data can be used to refine the curriculum and make the informed decision about which topics need more focus or modification. Predicting student outcomes, AI can use past performance data to predict future success rate, allowing educators to modify the curriculum or teaching strategies to improve student outcome. Feedback loops for improvement. AI tools can provide real-time feedback to instructors, helping them identify whether the current curriculum and teaching methods are effectively helping students meet learning objectives. Content creation and curation. Content generation AI can assist in generating medical content such as case studies, quizzes, and scenarios based on real life data. This can be especially useful in creating clinical scenarios for medical students to practice diagnostic reasoning. Curating relevant resources, AI can curate and recommend learning resources, for example, research articles, videos, clinical practice guidelines based on specific topics to the curriculum, helping students access up to date evidence based information. Virtual patients and simulation AI can power virtual patients, allowing medical students to practice diagnostics and treatment in a simulated environment. This helps bridge the gap between theoretical knowledge and practical application, especially in complex medical conditions. Interdisciplinary integration connecting medical receptor disciplines through AI to enhance collaborative learning. Interlink medical disciplines, AI can help in integration of various subjects like anatomy, physiology, pharmacology, and pathology to ensure that they are connected and reinforce each other throughout the curriculum. Collaborative learning, AI can help medical students collaborate across disciplines, creating interprofessional learning opportunities by integrating content and assessment from multiple areas like nursing, pharmacology, and clinical practice. AI-based learning platforms like Khan Academy, Coursera, and MedEd Portal curate medical content and track student progress. AI tools for competency-based assessment, OSCE, and virtual patient simulators simulate clinical cases, track decisions, and assess clinical reasoning skills. Curriculum management software tools like Zythos, XYTHOS, and Blue by the Labster creates dynamic curriculum maps, ensuring competencies and objectives are met. Well, tips to harness the power of AI for curriculum mapping. First, navigate changing accreditation requirement. LLMs are capable of standard alignment analysis to identify substantive changes, map related standards, detect modifiable, edit, removed, or changed requirements, and analyze the impact on compliance needs when accrediting agencies revise guidelines. This application reduces the time required for curriculum map updating by 2 working days. Mapping additional competencies to an existing curriculum is the second tip. AI models can analyze how to embed novel competencies such as critical AI appraisal in healthcare into existing curricular maps using Kern's framework. The use of the model reduced faculty time to outline an initial approach by 50%. Concept to integrated need, concepts to targeted need assessment. In curriculum keywords mapping, AI can systematically map a list of keywords to content embedded within curricular objectives to identify the inclusion or frequency of a specific subject. Strategies like using the persona pattern and integrating the keyword list directly into the prompt improve efficiency and reliability. F4 is map training, year specific competency based objectives for rotations. AI models can assist educators in drafting progress, competency based goals, and measurable objectives by training your PG of year 1, 2, and 3 specifying increasing responsibility with finalized objective that met accreditation standards were completed within an hour, demonstrating AI's efficiency. Tip 5 PEP accreditation requirements, competencies, and content description to educational learning objectives. LLMs can summarize, generate, and tabulate content features from institutional specialty or licensing content list alongside learning objectives. This process is useful for conducting a curricular gap analysis to identify content features falling outside existing objectives. Using the AI model reduce the time required for review and appropriate linking by over 50%. Tip 6 restrict the LLMs to a specific knowledge base when aligning requirement or educational research to institutional or assessment methods. By configuring the LLMs to reference uploaded standard and educational research like learning concepts related to structured verbal feedback. Educators ensure recommendations are precisely aligned, prompting the AI to provide exact section numbers and page references, streamlining the verification of alignment and accuracy. So we will discuss further 6 points later. These are the first 6 tips. We, we were on to the cons 4 steps, educational matters, and tip number 6 was to restrict the LLMs to a specific knowledgeable knowledge base when aligning requirements or educational research to institutional or assessment methods. Tip 7 is the use tables for comparative analysis in developing educational strategies. LLMs can generate comprehensive comparison tables declining different instructional measures, detailing different instructional methods, for example, self-directed learning, simulation-based learning, across critical factors like learner autonomy, cognitive load, scalability, and faculty resource needs. This digestible format supports evidence-based decision-making by faculty. Tip 8 is mapping best practices and educational methods to goals and objectives. LLMs can link active learning strategies which promote better retention to specific learning objectives, especially when new approaches are difficult to envision. Although LLMs generate novel ideas and save time, human review is essential to ensure accuracy and feasibility. Step 5 is implementation, and there are 2 tips as well here for the same. Tip 9 map faculty development needs to curricular objectives. AI models can review objectives, for example, those stressing interprofessional collaboration or system based practice, and suggest areas where faculty may require additional training or resources. This process provides an initial framework to align faculty development with curricular demands, bridging a common gap in systematic need assessment. Tip 10 is create an implementation plan and checklist. LLMs can generate a comprehensive implementation guide and checklist rooted in Kern's framework. This proactive approach saved an estimated 32 hours of faculty and administrative time by anticipating and addressing implementation design elements such as temporal organization, resource requirement, and risk mitigation. Kern's step 6 is evaluation. 11. Write multiple choice questions mapped to specific learning objectives. LLMs are effective tools for MCQ generation. Educators can produce precise, high quality MCQs by constraining the model to specific learning objectives, learner characteristics, and required level of Bloom taxonomy. For example, application of knowledge. LLMs reduced the time required to write a single MCQ by 80%, although human oversight is must to identify any inaccuracy. 12th tip is aligning programmatic evaluation with accreditation requirements and programmatic objectives. LLMs can function as an idea generating collaborator to co-design framework for improved assessment strategies for foundational competencies such as system-based practice, utilizing a single prompt to generate an assessment framework saved faculty 4 hours involved in generating ideas and organizing novel approaches. The output framework can include multiple assessment methods like direct observation, written assessment, and simulations. So unlocking the power of Google Classroom. Free and easy to use platform centralizes assignments, resources, and communication to one digital space, enables efficient management and tracking of student progress, enhances classroom organization, and streamlines communication, seamlessly integrates into existing teaching networks, accessible from any device supporting learning environments, empower educators to focus more on teaching and less on administrative tools, empower student enrollment in Google Classroom, streamline. So you will invite students, send invitations via email, or share a unique class code to connect students instantly. After that, students will accept and join effortlessly by accepting invitation, ensuring quick access to their classes. You will manage multiple classes and oversee all classes and monitor enrollment status efficiently through a centralized dashboard. Mastering activity management in Google Classroom. Create, assess, and communicate seamlessly to boost student engagement and classroom efficiency. Create assignments with precision. Add clear due dates to keep students on track and meet the deadlines. Attach detailed grading rubrics to enhance transparency and fairness. Upload necessary resources and instructions directly within the assignment. Second, integrate quizzes via Google Form. Embed quizzes seamlessly, streamline student assessment, use forms automatic grading to save time and provide instant feedback, customize questions to align with the lesson objective and learning goals, post announcement to engage students, share timely updates and reminders to maintain classroom connection, use engaging language to encourage participation and attention, and pin important messages for easy access throughout the course. Master Google Classroom with a live demo. Learn step by step how to create and set up a Google Classroom. Add students seamlessly assign tasks, gain hands-on experience with the platform's intuitive interface, and build confidence using digital tools to transform your teaching. Thank you. Oh, when and how to disclose AI use in academic publishing. AAME Guide number 192. It's a very good article written on generative artificial intelligence, and we will overview what are the roles for disclosing AI in harnessing.
frame this around a really important concept that they call establishing a fairer footing.
A fairer footing. What does that mean in this context?
Well, what's fascinating here is that this concept addresses a long-standing structural imbalance in global research. Because, the predominant language of scientific, medical, and educational literature is English.
Right. It's an English first club.
Exactly. So if a researcher is operating out of a university in the global south or just any region where English is not the primary language, they face an immediate steep disadvantage.
Because they have to translate everything.
Right. Their actual research might be methodologically flawless, but if the phrasing in their manuscript does not match the specific and honestly often rigid stylistic expectations of a Western English language journal, they face a much higher rate of rejection.
It's totally unfair. It's like asking people to run a marathon, but telling half the runners they have to wear heavy boots because they aren't native English speakers.
That's a great way to put it.
And the native speakers get high-end running shoes. Generative AI is suddenly offering those disadvantaged researchers the running shoes. It translates, it smooths out the syntax, it just bridges that massive linguistic gap almost instantly. But is it fair if we then penalize them for wearing the shoes?
Well, what's fascinating here is how that analogy holds up. The running shoes analogy works great for grammar, but it kind of breaks down when we look at the underlying logic of how these models actually operate.
Okay, how so?
Because a running shoe doesn't change the path you run, but an LLM might subtly change the actual argument a non-native speaker is making, just to sound more like Western English-centric research.
Wait, really? It alters the argument itself?
Yeah, because these models are trained heavily on Western data. So when a researcher asks the AI to just, polish their English, the AI isn't just fixing subject-verb agreement, it is often rewriting the text to match the semantic patterns of its training data.
Oh, wow.
So the tension here is whether we are actually helping these scholars express their unique perspectives, or if the AI is inadvertently erasing their cultural voice just to make it palatable to an English-speaking editor.
That is a critical distinction. The tool is acting as a cultural filter, not just a grammatical one.
Exactly.
But assuming the researcher is carefully managing that filter, the AI is undeniably democratizing the actual writing process for a lot of people.
It absolutely is.
So if the AI is doing so much of the heavy lifting, like if it is brainstorming the ideas, structuring the methodology section, and doing the translating, a lot of people are asking a very logical question. Why don't we just list the AI as a co-author on the paper?
Yeah, and that debate flared up immediately after the release of ChatGPT. Some early papers actually did list ChatGPT in the author block.
I remember seeing a few of those.
Right. But international guidance bodies moved incredibly fast to shut that down. I mean, the Committee on Publication Ethics, the International Committee of Medical Journal Editors, and major academic publishers like Taylor and Francis all issued strict guidelines prohibiting the listing of AI tools as authors.
I want to push on the logic of that prohibition for a second. Let's play devil's advocate.
Sure.
If I'm an executive and I hire a highly skilled, brilliant human ghostwriter to draft a 50-page annual report based on my notes, I review it, I sign my name to it, but we still acknowledge the ghostwriter's existence. They get paid, they get a nod.
Right, they are acknowledged.
Well, an AI is basically untiring ghostwriter. If an AI writes 90% of the text in a scientific paper, refusing to name it as an author kind of feels like human ego. So what does this all mean? Are we just protecting our territory?
It's a fair question, but defining authorship strictly by who generated the most words fundamentally misunderstands the legal and professional function of a byline in scientific literature.
Okay, how so?
The prohibition against AI authorship really has nothing to do with technical capability or human ego. It is entirely about scholarly accountability.
Accountability.
Right. When you put your name on a published piece of research, you are assuming legal, moral, and professional liability for every single claim in that document.
Right. If there's a mistake, you have to answer the emails when someone finds a flaw in your methodology.
Exactly. And it goes much further than just answering emails. You have to formally approve the final manuscript. You have to legally declare any conflicts of interest.
Which a computer obviously can't do.
Precisely. If it turns out the data in the paper was fabricated or a patient was harmed because of a flawed clinical recommendation you published, your reputation, your career, and potentially your legal standing are on the line.
That makes a lot of sense.
A machine cannot bear liability. You cannot fire an algorithm. An LLM cannot manage a conflict of interest. It cannot feel professional shame, and it cannot be held legally accountable for fraud.
Right, because it is a piece of software
Yeah.
not a legal entity.
Right.
So you can't sue ChatGPT.
Exactly. Acknowledging that software assisted you is fundamentally different from granting it authorship. Authorship is essentially a contract of liability. Therefore, the human author must remain fully responsible for the accuracy and originality of the work,
Even if the machine wrote most of it.
even if the AI generated 95% of the text.
Okay. But if the human has to take all the responsibility, that introduces a massive vulnerability for you. Because what exactly are you taking responsibility for?
That's the terrifying part.
This leads right into the immense risks of relying on AI, specifically accuracy, bias, and privacy. The source material explicitly warns that any output from an AI must be treated as unverified notes, not finished scholarship.
And that requires a complete shift in how we traditionally view computational output. For decades, we have viewed computers as calculators.
Like an adding machine.
Exactly. If you type a complex equation into Excel, you expect the absolute objective mathematical truth as an output. You do not double check Excel's math.
Never. I just trust it blindly.
We all do. But large language models are not calculators. They do not compute objective truth. They predict language. They calculate the statistical probability of which word should follow the previous word based on patterns of their training data.
Which is the exact mechanism that leads to hallucinations, right?
Yes, exactly. The AI will completely fabricate references, quotes, and data with absolute linguistic confidence.
Because it's designed to sound plausible, not to be factually accurate.
Right, it's a very convincing liar.
The source mentions studies showing that these models frequently invent academic citations completely out of thin air.
Yeah, it's a huge problem.
Like a researcher might ask the AI for a literature review on a specific topic,
Different.
and the AI will output this beautifully formatted list of sources. Gives you a real sounding author name, a highly relevant paper title, a legitimate journal name, and even a fabricated DOI number.
And it looks perfectly real.
Exactly. If you don't actually click the link or search the database, you would never know the paper doesn't actually exist. So authors are now forced to manually verify every single quote, stat, and line of code.
And that manual verification process brings us to the issue of plagiarism, or what the source terms agerism.
Agerism, that's a clever term.
It is, because LLMs do not adhere to academic attribution norms. They do not understand the concept of intellectual property at all. They have ingested millions of texts, and when they generate an output, they blend those statistical patterns together without citing the original human creators.
So if you copy and paste AI's output directly into your manuscript, you might be inadvertently plagiarizing a human author whose work the AI scraped during its training phase.
Yes. You could even end up self-plagiarizing your own previous work if the model happened to ingest your past publications.
That is wild. And beyond plagiarism, there's the issue of bias. Because it learns from historic data, it just perpetuates whatever bias was in that data.
Right. Exactly. It functions as a mirror reflecting the historical prejudices present in that training data. The AAME guide cites a really striking study to illustrate this.
Oh, the DLE3 study.
Yeah. Researchers asked DLE3, which is a generative AI image tool, to create images representing Australian medical students.
And the results were just drastically skewed. I mean, 92% of the individuals in the generated images had light skin.
Right.
And nearly 59% were male. That is a gross misrepresentation of the actual demographic reality of Australian medical students today.
And the mechanism behind that result is crucial to understand. DLE3 did not consciously decide to exclude certain demographics. It doesn't have intent.
It's just doing math.
Exactly. It generated those images based on the billions of images and associated text tags it was trained on. Historically, medical literature and stock photography have overrepresented white male subjects in the role of doctors. The AI simply looked at the historical statistical distribution and replicated it.
It assumes the historical baseline is the permanent reality.
Right. And if a human researcher is using these tools to generate visual aids or to synthesize data on patient populations, and they do not actively interrogate the AI's output, they will inadvertently hard-code those historical inaccuracies back into modern research.
So verification is no longer just checking your own math or checking a citation. It requires auditing a machine's logic to see what data it is silently excluding.
That's a perfect way to summarize it.
Well, that covers the risk of the output. But there is an equally severe risk on the input side, data privacy.
Oh, this is a massive issue.
Let's say you are a researcher conducting a clinical study. You have a massive document of interview transcripts from vulnerable patients or proprietary data about a new drug trial. The instinct is to drop that 50-page document into a public LLM and ask it to summarize the key themes.
Which is incredibly dangerous.
Right, because the moment you paste that text into the prompt box, you might be violating confidentiality agreements.
The terms of service for many public generative AI tools explicitly state that user inputs can be used to train future versions of the model.
Right, it's right there in the fine print nobody reads.
Exactly. So if you input raw, anonymized patient data or confidential institutional protocols, you're essentially transmitting restricted information to a third-party technology company.
Let's pull this out of academia to look at the real-world application for you, the listener. Imagine you are a mid-level manager at a company.
Okay.
You record a highly confidential quarterly strategy meeting. You run the audio through a transcription software, and then you paste the transcript into a public AI tool to generate a summary for your team. You have just uploaded your company's proprietary strategy, specific financial targets, and internal weaknesses into a data set that might be used to train the next version of the AI.
Which means 6 months from now, an employee at a rival company could ask that same AI tool, what are the common weaknesses in current business strategies?
Wow, yeah.
And the AI might generate an answer that closely mirrors the exact proprietary information you uploaded.
That is terrifying. So the guide emphasizes that anyone handling sensitive data must verify with their institutional review boards or IT security teams to ensure their tools operate within a closed environment.
Right, an environment that does not train on user data.
Okay, so we have established that AI is a massive liability regarding accuracy, bias, and privacy. This brings us to the immense complexity of regulating it. Because to write a rule about AI, you first have to define what actually counts as AI use.
And the lines there are incredibly murky.
Yeah, the boundary between human writing and machine writing is just disappearing.
The guide attempts to categorize this by drawing a line between AI-assisted content and AI-generated content.
Okay, what's the difference?
AI-assisted content generally refers to work where the human authored the initial text but utilized AI to polish it.
So like fixing grammar or spelling.
Exactly, improving syntactic flow, that sort of thing. The human remains firmly in control of the ideation and the initial framing. And most journal policies currently treat this like an advanced spell checker and do not mandate explicit disclosure.
Okay, but AI-generated content is the other side of the line.
Right. This is text where the initial draft was created by the AI based on a prompt. Even if the human author goes back and heavily revises that text later, the seed of the paragraph originated from the machine.
And usually that requires disclosure.
In almost all current academic policies, yes, AI-generated content requires explicit disclosure.
But here's where it gets really interesting. How do you define the origin of the text once the editing process begins? Because the line between assistance and generation is practically impossible to enforce once an author starts revising.
It's a complete gray area.
Let's test the boundary with the ship of Theseus analogy.
Oh, I love this.
For those who don't know, it's a classic philosophical thought experiment. If you take a wooden ship and over the course of 10 years you replace every single rotting plank with a new piece of wood, is it still the same ship at the end?
Right.
Let's apply that to a manuscript. I prompt an AI to write a paragraph summarizing a scientific concept. It spits out 5 sentences. It is clearly AI generated. I need to disclose it.
Yes, under current guidelines, that is a clear-cut generation.
But what if I read the AI's paragraph and I delete 1 sentence because I think it's weak? Then I change 3 adjectives. Then I rewrite the concluding sentence to sound more like my own voice.
Okay, so you're actively editing.
Right. I've now altered 50% of the text. Is it still AI generated? What if I spend a week editing and eventually replace every single word the AI originally generated, but I retain the underlying logical structure and the sequence of arguments the AI suggested?
You replaced all the planks.
Exactly. I replaced all the planks one by one over a week. At what point does the AI's idea become my writing? Is it still the AI's ship?
This is the exact dilemma journal editors are facing right now. And the authors of the AME guide address this by looking at the concept of continuity. They ask how much continuity of the original AI text remains in the final product.
But there's no objective metric to measure continuity of thought versus continuity of syntax, right?
None. Because there is no universal answer, individual journal policies are fracturing. They are highly inconsistent and constantly evolving.
The source outlines just how chaotic this is right now. It's wild. For instance, the Journal of the American Medical Association, JMA, has a policy stating you do not have to disclose basic grammar checks, but essentially any other use needs to be reported.
Right.
But then Springer Nature has taken a hardline stance, completely prohibiting any generative AI images from being published in their journals, regardless of how much human prompting was involved.
And meanwhile, the journal Nature has stated that AI-assisted copy editing does not need to be declared because they believe it does not involve autonomous content creation.
The inconsistency creates a total labyrinth for researchers. And the gray area gets even darker when you look at complex prompting. What happens if an author uploads their own human-generated notes and uses specific prompts to have the AI write them into a specific textual form?
Right, like if a researcher spends 3 months taking meticulous original field notes, they have 20 pages of raw human-generated observations. They upload their own notes into an LLM and instruct the AI to organize those notes into a standard methodology section.
The ideas are 100% human.
Exactly, but the actual sequence of the words was generated by the machine. So is that assistance or is that generation?
It's a hybrid that current definitions struggle to categorize. And because policies are a moving target, the guide strongly recommends a golden rule for all authors. Disclose when in doubt.
Disclose when in doubt, it's the safest approach.
It is a safe legal strategy. But I want to dig into the philosophical why. Because right now, the entire system relies on an honor code. There is no software that can accurately detect if an AI wrote a heavily edited paragraph. So why do readers actually need to know if an AI was involved?
Well, the foundational pillars of scientific publishing are transparency, integrity, and accountability. Readers and editors need transparency to critically evaluate the manuscript.
Sure, but the AME guide introduces a much deeper, more philosophical threshold for when disclosure is necessary, don't they?
They do. They argue disclosure is warranted whenever an AI tool materially shapes the research or the manuscript.
And what does materially shapes actually mean in practice?
They define this as an epistemic threshold. Epistemology is a branch of philosophy concerned with the theory of knowledge. It asks how we know what we know, how we validate facts, and how we justify our beliefs.
Right, the study of truth, basically.
Exactly. The authors of the guide argue that AI has crossed a line from being a passive tool to becoming an active participant in the creation and transformation of knowledge.
This is where we need to draw a sharp contrast. A microscope is a tool. A researcher uses a microscope to look at a cell. The microscope magnifies reality, but it doesn't interpret it.
Right. The human looks through the lens and makes a judgment.
The microscope is totally passive. But an LLM isn't just magnifying data.
No, an LLM acts as an interpreter. The guide states that even though AI completely lacks human agency or consciousness, it now functions as the originator of our beliefs and their content.
That is a massive paradigm shift. If you ask an LLM to conduct a literature review on a controversial topic, it might scan 1,000 papers and summarize 50 of them. The AI has just made an editorial decision.
It decided which 50 papers represent the reality of the topic, and it silently excluded 950 others based on the opaque weighting of its algorithms.
The AI acted as a gatekeeper of knowledge. If an AI structured your core argument or decided which literature to summarize, it shaped how you view the truth of your subject. The reader desperately needs to know the lens through which the data was processed.
Exactly. If a human does a literature review, they have inherent biases, but we can evaluate a human's methodology. We can look at a machine's output, but we cannot easily audit the exact statistical weights that led it to prioritize one paper over another.
Think about this from the perspective of reading a news article. You'd want to know if a human reporter interviewed sources, or if an AI scraped the internet and hallucinated the quotes. It changes how much you trust the core claims.
Absolutely. The presence of the machine materially changes the epistemological nature of the document. You have to know who or what originated the claims to evaluate their validity.
This brings up a major behavioral problem highlighted in the source, because we are talking at length about telling the public and the journals about AI use. But the guide points out a pervasive issue happening internally, before the paper is even submitted.
Right, happening behind closed doors.
Researchers are routinely hiding their AI use from their own co-authors.
The guide refers to this as a lack of internal disclosure. Early literature on AI adoption shows that explicit conversations about AI use are simply not happening early in the project lifecycle.
Why not, though? I mean, if a team is overwhelmed with data, and one researcher figures out how to use an AI to code data in half the time, you would think they would be eager to share that with the team.
You would think so, but they hide it because of what the authors identify as the disclosure penalty.
The disclosure penalty.
Yeah. Despite the widespread adoption we discussed earlier, there is still a deep-seated stigma attached to using AI for intellectual work. Authors hesitate to tell their colleagues because they fear professional judgment.
They think it's cheating.
Exactly. They worry that if they reveal they used ChatGPT to draft a literature review, their peers will question the legitimacy of the work, the creativity of their insights, or their actual intellectual contribution.
It's essentially academic guilt. It's like hosting a dinner party. You make a beautiful cake from a boxed mix, but you hide the box in the trash before your guests arrive because you want them to think you spent hours measuring flour.
That is a brilliant analogy.
Right. But in science, hiding the box mix can get your whole team's paper retracted.
It creates catastrophic ethical liabilities. Because if a junior researcher uses an AI to generate a section, fails to verify the citations, and never tells the lead author might submit that paper to a major journal.
And when the peer reviewers eventually discover that the citations are totally hallucinated, the paper gets retracted. And the entire team's reputation is permanently damaged because of an undisclosed ethical violation.
The Gaia emphasizes that research teams must implement deliberate steps to normalize these conversations. They cannot be treated as confessions of guilt. They need to be normalized as standard methodological planning, just like discussing who gets to be first author.
Normalizing it strips away the shame and ensures everyone is legally protected. So let's assume a researcher overcomes the internal stigma. They have the conversation with their lab and they are ready to submit the paper. They know they need to disclose their AI use to the journal. The problem is, how do you actually write that disclosure without it sounding like you're confessing to a crime?
Authors frequently fall into the trap of writing defensive, vague disclosures. The AME guide stresses that disclosing AI use should be treated as routine, unemotional methodological reporting.
Okay, so keep it clinical.
Exactly. If a researcher uses Microsoft Excel to generate a scatter plot, they do not write a paragraph apologizing for not doing the math by hand. They simply state the software and the version used as a factual component. AI disclosure must adopt that same tone.
To structure this, the guide initially references the Weaver Artificial Intelligence Disclosure Framework, known as the 8 framework, which breaks disclosure down into the who, what, why, and how much of AI involved.
But the authors of this specific source document go further. They propose their own framework specifically for health professions education research, which they call the AIH Peer Framework.
The AIH Peer Framework. And this includes 8 key practices, right?
Right, 8 distinct practices for comprehensive disclosure. The first practice is to specify the exact model and the specific version used. Simply writing, we use ChatGPT is functionally useless to a reader.
Right, because ChatGPT 3.5 from 2022 is a completely different mechanism than a model like GPT-4 or Gemini Advanced. They have drastically different parameters and hallucination rates. So you have to say, we utilize ChatGPT version 4.0.
Exactly. The second practice requires detailing the specific activities the AI performed. Don't just say, we used AI for coding. In a research context, coding could mean writing a Python script, or it could mean qualitative analysis of interview transcripts.
The reader has to know exactly what the machine touched. So say, we utilized AI to extract recurring themes from patient feedback.
The third practice addresses the data privacy issue. You must declare if participant consent was obtained for uploading data. Did the patient consent to their transcript being processed by a third-party server?
Makes sense. And the fourth practice is related, indicating the specific steps taken to protect that data. Like, did you go into the settings and turn off the improve the model for everyone feature?
Right, it proves you actively manage the privacy. Now, the fifth practice introduces a concept that is truly fascinating: negative disclosure.
Oh, I love this part.
It suggests explicitly stating when AI was not used, particularly in phases where a reader might logically suspect it was.
It's fascinating that we are entering an era where you have to explicitly state a human actually thought of this part. Like, an LLM was used to format the references, but was not used to generate the interpretive analysis. It highlights the areas of research we still consider sacred to human intellect.
We are defining the value of human intellect by explicitly stating what tasks we deny the machine. The sixth practice is to reference the specific journal or institutional policies you are following.
Just to show you read the rules.
Exactly. The seventh practice is making a final statement assuming full responsibility. Even if there isn't a checkbox, write a declarative sentence. The HUMI authors assume full responsibility for the accuracy and integrity of all content.
You are formally signing the contract of authorship.
And the final, eighth practice, is to keep records of the prompts. Maintain an audit trail. Save the PDF of the chat log, or share a link to the conversation. If anyone questions the origin of the data, you can prove how the AI was directed.
The framework is incredibly thorough, but the guide also explicitly lists what authors should avoid doing, what not to do. Don't write vague disclosures like, we use ChatGPT for research. That tells the reader nothing about the epistemic impact of the tool.
Vague disclosures are essentially virtue signaling. You're trying to check a compliance box, but providing no meaningful information. And don't apologize or be overly defensive. Just state the facts.
All right, so we have established incredibly strict rules, philosophical boundaries, and detailed frameworks holding the human authors accountable. But what happens when the paper is finally submitted and the peer reviewers evaluating the work want to use AI to speed up their own jobs?
This creates one of the most intense points of friction in the current publishing ecosystem. Using generative AI in the peer review process is heavily discouraged and often strictly prohibited by journals.
Like Academic Medicine and MedPortal.
Right. The primary reason for that ban is confidentiality. When a human author submits a manuscript for peer review, it is a privileged, unpublished document. If a reviewer uploads that into an LLM just to get a quick summary, they are breaching the confidentiality agreement.
They were feeding unpublished scientific data into a third-party commercial server.
Exactly. But the secondary reason touches on the fundamental purpose of peer review. AI lacks domain expertise and real-world lived experience.
A machine does not practice medicine.
Exactly. Therefore, it lacks the critical human judgment necessary to assess if a paper is genuinely novel or grasp the subtle ethical nuances of a clinical trial. It acts as an unhelpful black box.
The guide actually points out a massive hypocrisy developing here. They use the phrase rules for thee, but not for me. Journals fiercely insist that an AI cannot be an author because a machine lacks moral responsibility. Yet, some reviewers are tempted to use that exact same unaccountable machine to pass judgment on human authors.
It is a glaring double standard.
It's like submitting your novel to a publishing house, and instead of an editor reading it to see if it makes them feel something, they feed it to a robot to see if the word count is right. The author is held to the highest standard of human integrity, while the gatekeeper outsources their job to a machine.
If we connect this to the bigger picture, if we remove human judgment from the peer review process, we strip the system of its core value. An AI can spot a formatting error instantly, but it cannot tell you if a piece of research will fundamentally change how a doctor treats a patient.
Which begs the ultimate question. With all of these strict frameworks, the blurry definitions, the equity issues, and the hypocrisies of peer review, where is this actually heading? The guide looks to historical technological shifts to try and predict the future of AI disclosure.
And historical parallels are vital here. We have experienced massive technological disruptions before. The introduction of calculators, word processors, spreadsheets, and statistical packages like SPSS were all once disruptive.
There was a time when using a computer to run a statistical regression was seen as taking a shortcut.
Exactly. But today, no one declares they used Microsoft Word's spell check. It is entirely assumed. The authors predict that eventually, generative AI disclosures will likely become minimized, routine, or vanish entirely once the use is normalized.
But we are not there yet. We are in a transitional phase, and there is an urgent need for more research on the equity implications. We talked about how AI offers a fairer footing for multilingual scholars. The data shows a substantial proportion of authors disclosing AI tools are from the Global South.
And this creates the ultimate policy dilemma. We desperately need strict transparency to protect the epistemological truth. But if journals implement overly aggressive policing or ambiguous rules, strict disclosure policies risk disproportionately burdening multilingual scholars or those from less resourced institutions.
If the penalty for a mistake is having your paper rejected, the researchers who rely on the tools the most are the ones most at risk. We could exacerbate structural disparities.
To mitigate this, new AI-specific reporting guidelines are emerging across different disciplines. There is Gamer for general medical research, Consort AI for clinical trials, and Prisma AI for systematic literature reviews.
We are essentially trying to build the regulatory airplane while we are already flying it. We are in the messy middle. We are living in the 5 to 10 year window where we have to awkwardly announce, I used a computer to help me think. 50 years from now, people will look back at these journal declarations and laugh at how quaint we were.
The goal should be norms that promote transparency without perpetuating inequality. It is an incredibly delicate balancing act.
We've covered how these tools are normalizing, much like spell check did, but I want to leave you, the listener, With a final provocative thought to mull over, something building on this source material. We established that LLMs are trained by scraping human-generated text from the internet. But right now, the internet is being flooded with AI-generated text and AI-generated academic papers. If normalization means everyone uses these tools, we are heading toward a massive Ouroboros scenario, a technological snake eating its own tail.
Model collapse.
Exactly. In 5 years, when they train their next generation model, they will be scraping an internet saturated with the outputs of their previous models. If future researchers use AI tools trained on previous AI-generated papers to write new AI-generated papers, at what point does human knowledge stop expanding and simply start echoing itself in an endless, perfectly spelled, grammatically correct loop?
That is the ultimate existential question. If the silent collaborator becomes the only voice generating the text, what happens to the human pursuit of truth?
That is something to think carefully about the next time you open up a chat window. Paste in a few bullet points and ask the machine for just a little help phrasing an email. Thanks for joining us on this deep dive. Education sphere with some benefits. Like every single character's arc has to perfectly align over 100 episodes. You can't have any plot holes. And furthermore, the entire narrative has to comply with strict, constantly changing network regulations.
Right. Except in this scenario, the network is a medical accreditation.
Exactly. The show Bible is housed in some labyrinthine learning management system. And the characters are future doctors holding actual human lives in their hands.
Yeah, that analogy really captures the sustained, grueling focus required for the task. Because curriculum mapping is it's the systematic alignment of educational content.
Okay.
You start with overarching standards, the absolute non-negotiable requirements of what a physician must know. Then you have to disaggregate those massive standards into highly specific, granular learning objectives.
Breaking it all the way down.
Exactly. And then you map those objectives to exact pedagogical strategies. And finally, you align all of that with specific evaluation methods.
It sounds exhausting.
It is intensely detail heavy. You're building codified, structured matrices so that anyone can transparently visualize how a single multiple choice question relates to a global accreditation standard.
But the introduction of AI into this rigid, heavily regulated environment hasn't exactly been smooth.
Oh, definitely. The source text uses a brilliant phrase to describe the current atmosphere. They state that medical education is experiencing an AI culture shock.
Yeah, that makes total sense.
No, it perfectly encapsulates the whiplash educators. On one side, there is profound awe. I mean, they're staring at a technological tool capable of executing in 30 seconds what would traditionally take a committee of highly paid professionals 3 weeks to accomplish.
Wow. Yeah.
But on the other side, there's deep existential apprehension. These are professionals whose entire careers are built on precision and evidence.
Right. And handing over the architectural keys of a medical program to an algorithm that, occasionally hallucinates facts, that's terrifying.
Absolutely terrifying. So our mission here today is to navigate that exact tension. We want to move you from a place of systemic resistance or generalized fear into a posture of practical, highly responsive adaptation.
I love that. Practical adaptation. Yeah. So to structure this enormous undertaking to build this medical show Bible without losing the plot, the authors ground their entire study in a foundational framework known as Kern's 6-step model for curriculum development. And to build any kind of lasting structure, you first need to survey the land. You have to know what the environment demands and what you currently.
Yeah, which brings us to the first 2 steps of Kern's model, and the targeted needs assessment.
Okay, let's dive into the blueprint phase because this is where the friction usually begins. Right?
Oh yeah, because accrediting agencies exist internationally and they're not static entities. They frequently revise their massive guideline documents.
And historically, when a new version drops, what happens?
Human educators have to engage in an agonizing process. They literally sit down, place the old monolithic document side by side with the new monolithic document, and manually scan for every single substantive change, addition, removal, or even slight modification of terminology.
Oh my gosh. Just staring at hundreds of pages of bureaucratic text, trying to play the world's highest stakes game to spot the difference.
Exactly.
It's not like a recipe for immediate burnout.
It is. The cognitive load of that task virtually guarantees human error. But the University of Washington team deployed an LLM to perform this exact standards alignment analysis.
They didn't just use any open source web interface.
No, they specifically highlight the necessity of using an AI with commercial data protections. When you are feeding proprietary institutional curriculum data into a system, you absolutely cannot risk that data being absorbed upstream.
Right, that security layer is the prerequisite.
Yeah.
But what really fascinated me was the mechanics of how they actually instruct the AI. Prompt strategy is where the true value lies.
Yeah, the prompting is everything.
They didn't just drag and drop the files and casually type, hey, what changed? They engineered a highly constrained prompt. I'll quote the authors directly here. They instructed the AI to strictly use the uploaded documents without conducting an online search to summarize the changes.
And that constraint fundamentally alters how the model processes the request.
How so?
Well, by explicitly forbidding an internet search, they artificially shrank the AI's universe of knowledge to just those 2 uploaded files. Large language models are built to be helpful, right? And if they find a gap in information, they will often pull from their vast parameter weights to fill that gap.
Which is how you get hallucinations.
Exactly. By placing a wall around the uploaded text, the authors forced the model to act purely as a comparative analytical engine rather than an open-ended generative one.
And the result they achieved that specific constraint were staggering. The AI successfully flagged the novel requirements and pinpointed the critical differences between the old and new accreditation standards.
And it saved them so much time.
It saved the curriculum team 2 full working days of manual grueling labor, 2 entire days handed back to the faculty,
Which is incredible.
and perhaps more importantly, the AI caught manual errors and omissions that the human reviewers had actually overlooked in previous cycles.
Because the machine possesses an untiring capacity for syntactic comparison. It doesn't simply be reading page 100. However, the authors are vigilant in noting that human oversight remains a fixed requirement.
Right, you can just blindly trust the output.
Exactly. The human experts still manually review the generated output to ensure contextual accuracy. Paradigm shift isn't about replacing the human here. It's about shifting the human's role from finding the needles in the haystack to simply verifying that the needles the AI found are, in fact, the correct ones.
That makes total sense. Which leads us into a scenario that feels a bit like the movie Inception.
Oh, the AI inception part.
Yes, we're talking about a needs assessment, and the institution realized they had a massive emerging gap. They needed to teach medical students about artificial intelligence. So they used an AI model to figure out how to teach humans about AI.
The meta layer here is just striking, but the administrative problem was very real. Medical curricula are mandated to undergo continuous quality improvement to incorporate emerging scientific knowledge. So the institution was tasked with implementing a novel undergraduate medical education curriculum focused on AI in healthcare. They had to embed a brand new competency that they termed critical AI appraisal into existing, already overcrowded curriculum paths.
And they didn't just ask the AI to write a syllabus, did they?
No, they prompted it to propose integration strategies using Kern's 6-step framework. And the output was a massive, highly structured architectural plan.
What kind of gaps did it?
Well, the AI identified foundational knowledge gaps that students would need to fill before they could even understand AI. Things like core statistical concepts, data literacy, and the methodologies used to validate algorithms.
What really demonstrates the power of natural language processing here is that AI is operating in a vacuum. It didn't just suggest a brand new, isolated 4-week course on AI, which would just completely disrupt the entire scheduling matrix.
Right, because that would be a logistical nightmare.
Exactly. Instead, it mapped these new concepts to existing educational elements.
It suggested weaving AI validation methodologies into the pre-existing evidence-based medicine modules.
Oh, that's smart.
Yeah, and it suggested adding the core statistical concepts into the established biostatistics courses. It provided a year-by-year breakdown of integration, complete with session objectives, and multi-level assessment methods.
It effectively cures the blank page syndrome.
Yes,
You aren't sitting in a committee meeting staring at a whiteboard for 4 hours debating where to fit a new lecture. You are looking at a 50% completed roadmap.
and the authors noted that this specific output reduced their faculty planning time by 50%. It gives the human experts a highly detailed skeleton that they can immediately begin to debate, edit, and refine.
The acceleration of the preliminary design phase is immense, but building the map is really only half the battle of the needs assessment. Often the challenge is proving what is already on the map. Medical schools frequently receive inquiries from governing bodies or even internal audits, demanding to know where exactly a specific topic is being taught across the 4-year program.
And finding the answer to that requires curriculum keyword mapping.
Mm.
You are hunting for highly specific subjects across thousands of disparate documents, syllabi, and objective pieces.
And to solve this, the authors utilized a prompt engineering technique called the persona pattern.
Okay, what is the persona pattern?
It's a cornerstone of advanced prompting. You explicitly instruct the model to adopt a specific identity.
Oh, so in this case, they told the AI, act as an expert in curriculum mapping in medical education.
Yes, but they didn't stop there. They integrated the exact list of required keywords directly into the prompt, and they severely limited the model's creative parameters.
So,
They explicitly told the AI that it was not allowed to invent or suggest new keywords outside of the provided list.
okay, give me an example of how that works in practice.
Sure. They provided the AI with a specific learning objective on their curriculum. For instance, an objective focused on identifying how social determinants of health can affect imaging services and ultimately lead to health disparities.
Okay.
Then they fed the AI the rigid list of approved keywords. The model successfully analyzed the objective and matched it to the keywords: social determinants of health, health disparities, and imaging.
Okay, let me push back on this process for a second.
Go for it.
If we're explicitly telling the AI to act as an expert, but then we are severely restricting its creativity, locking it into a predefined list of words, aren't we basically just using a multi-billion-dollar supercomputer as a glorified Control-F search function? Like, why introduce an LLM into a process that a standard database query could theoretically handle?
That is a great question. The distinction between a standard database query and an LLM is a difference between syntactic matching and semantic understanding.
Syntactic versus semantic. Okay, break that down.
The Control-F keyword search is purely syntactic. It requires an exact string of characters to yield a result. Imagine a learning objective that discusses financial barriers to receiving an MRI. If you run a standard database query for the required keyword social determinants of health, you will get 0 results. The exact words are not there. To an auditor, it looks like you are failing to teach the subject.
Just because the professor who wrote the objective used different vocabulary than the accreditation board.
Exactly the problem. But an LLM utilizes natural language processing. It doesn't just look at characters. It understands the semantic weight of content.
Wow.
The neural network understands that financial barriers is a concept inextricably linked to the broader category of social determinants of health. It knows that an MRI falls under the umbrella of imaging. It performs contextual matching.
So it's acting as a semantic bridge between the professor's natural language and bureaucracy's rigid taxonomy.
That is the precise mechanism of value. And that is why constraining its hallucinations is so vital. You want to leverage its massive textual understanding of language, but you strictly want it to output only the approved vocabulary of your institution.
You need the brain of an expert, but the discipline of an auditor.
That's a perfect way to say it.
That distinction makes the entire endeavor make sense. It's not just finding words, it's understanding the meaning of the curriculum, which transitions us organically from finding the gaps in the map to deciding what we're actually going to do.
Right, moving on to the next phase.
Once the needs are assessed, we have to set the destination. This is current step 3, goals, objectives.
And moving from analysis to generation requires a different approach. You know the gaps. Now you have to explicitly define what the learner must achieve. The AI shifts from being a reader to being a drafter.
And in medical training, drafting objectives is uniquely complicated because of the concept of progressive responsibility.
Yes, the authors demonstrated this by using the AI to design competency-based goals for an orthopedic trauma rotation. But they needed these goals separated across 3 entirely different years of residency: PGY1, PGY2, and PGY3.
And for those unfamiliar with medical acronyms, that translates to postgraduate year 1, 2, and 3.
Right. A first-year resident and intern is operating under a vastly different set of expectations than a senior third-year resident. The educational goals must reflect that escalating difference.
So how did the AI handle that progression?
When prompted to generate these layered objectives, the AI demonstrated a highly nuanced understanding of this approach. For the PGY1 residents, the AI drafted an objective heavily focused on foundational skill sets.
Like what?
It stated they were tasked with reviewing supervisor feedback after each trauma case and implementing one actionable improvement plan.
It's a very grounded, receptive goal. Learn to take feedback and achieve 28. What about the second years?
For the PGY2 residents, the AI recognized the need for analytical application. The objective shifted. The second-year residents were tasked to review current trauma care literature, select evidence-based findings, and actively apply them to at least 3 clinical cases.
Wow.
And explicitly documenting the improvements in each of them.
So they moved from just receiving instructions to independently applying established research to real patients.
Exactly. And finally, the AI generated the objective for the PGY3 residents, shifting the paradigm entirely toward leadership and systemic.
Leading the department.
Yes. The senior residents were tasked with conducting a comprehensive review of departmental trauma care practices, presenting evidence-based recommendations to the entire staff, and tracking measurable department-wide improvements by clinical rotation.
And the AI drafted this entire staggered progressive competency ladder, moving from personal feedback to clinical applications to departmental leadership in under an hour.
Under an hour. It delivered a perfectly scaled skeleton for the program directors to work on.
It removes the friction of building the architectural framing, allowing the experts to immediately start polishing the finishes. But this drafting process exposes one of the most significant vulnerabilities of using AI, right?
It does. A phenomenon the authors documented closely for conducting a gap analysis between broad standards and specific objectives.
This is the danger of what the authors call high sensitivity. They were attempting to connect broad accreditation content descriptors phrases like hemodynamics, blood flow, pressure, to highly specific educational learning objectives within their system.
The AI successfully mapped those broad terms to a specific granular objective explaining the fluid flow equation and demonstrating how its mathematical components apply to the human cardiovascular system.
And the quantitative result was fantastic, right? The authors noted that utilizing the AI reduced their manual review time by over 50%.
Yes, the speed was there, but the qualitative experience was a bit chaotic. Here is where the underlying mechanics of the AI become a hurdle. The model exhibited high sensitivity, meaning it was aggressively eager to make concepts fit.
Aggressively like that.
It would find linguistic or thematic connections where the actual educational relevance was incredibly weak or just completely non-existent.
Because the AI operates on probabilistic interpretation. If it sees blood pressure in standard A and blood pressure mentioned offhandedly in standard B, it draws a massive bright line between.
Regardless of whether standard B is actually teaching the concept or just mentioning a patient's vitals in passing.
It is like hiring a wildly overenthusiastic caffeinated intern.
Oh, absolutely.
You ask them to find connections in the files. They come back to your office, pointing at a corkboard, completely covered in red string, connecting every single document to every other document.
Yeah, the red string everywhere.
Box. I connected the cardiovascular fluid flow equation to the history of the stethoscope, and I linked that to the cafeteria sodium policy. It is mathematically connected, but practically useless.
It requires a human manager to walk inside and say, take down 80% of the string. Doesn't make any sense.
That dynamic is exactly what the researchers do. The human educators can step in, evaluate the scrolling output, and implement follow prompts to aggressively constrain the model.
They had to force the AI to tighten its specificity and remove the extraneous, loosely correlated data.
The AI's desperation to be comprehensively helpful manifests as a flood of false positives. It is the ultimate proof that outsourcing the final judgment to the machine is impossible.
Right. Human oversight is the only mechanism that filters mathematical correlation to educational relevance.
So if we follow the blueprint, we have found the gaps, we have established the progressive goals, we have navigated the red string to lock down our objectives. Now we reach the practical core of the entire endeavor, the how.
Current step 4.
Exactly. Educational methods. We have to determine the actual pedagogical strategies to teach these specific objectives. And in this phase, the AI evolves from an administrative assistant into a high-level instructional design consultant.
The challenge of instructional design is ensuring that the teaching method aligns with the evidence. The authors wanted to align their program standards with a highly specific educational concept, structured verbal feedback.
But they recognized a danger here. If you ask an LLM a broad question of feedback, it will generate a generic blog post style summary. It will give you conversational platitudes.
Right. They needed rigorous, standard-aligned methodology, not a LinkedIn post.
So to achieve this, they utilized a specific prompting strategy, restricting the LLM to a highly defined knowledge base. They uploaded both the academic research concepts regarding structured feedback and the specific rigid program requirements of their institution directly into prompts.
And by establishing that dual context window, they forced the AI to cross-reference the pedagogical theory against the institutional mandate.
What did it output?
The model synthesized the data and generated actionable best practices, such as implementing regular structured verbal feedback sessions that provide timely guidance focused explicitly on documented strengths and areas of improvement. But the crucial element was the justification.
It actually cited its work.
It did. The AI specifically noted that learners prefer structured verbal feedback because the uploaded research proves it associates with objective measures of improvement. Furthermore, it explicitly cited the exact institutional standard requiring timely formative evaluation. It didn't just tell faculty what to do, it provided the evidence-based and compliance-based arguments for why they had to do it.
The amount of labor saved there is immense. Instead of an educator spending 3 days digging through PubMed to find literature to justify teaching method to a curriculum committee, the AI provides a comprehensive, synthesized argument with the structural citations already built in.
Though, keeping our previous warnings in mind, a human still has to click the links and ensure the AI didn't hallucinate the research.
Always verify. The synthesis of complex pedagogical options is where the AI truly excels, particularly when formatting that data for human decision-making. The authors demonstrate this by using the AI to generate comparative analysis tables.
Yes, and I think this specific application might be the most transferable insight for anyone listening, regardless of your industry.
Oh, absolutely. The authors were tackling a competency known as systems-based practice.
Systems-based practice is an inherently difficult concept to teach. It requires a medical learner to understand how a single patient interaction is embedded within a massive complex healthcare system.
They consider insurance structures, resource allocation, community care networks, socioeconomic factors that align.
It is. The faculty needed to determine the best way to teach this, and they wanted to compare 3 distinct methodologies: self-directed e-learning, case-based learning, and simulation-based learning.
And instead of asking the AI for a summary to yield pages of dense paragraphs, it prompted it to generate a detailed comparison table. They dictated the exact columns of that table.
They asked the AI to compare the 3 methods across the factors: the level of learner engagement, the scalability of the method, the cognitive load placed on the student, the real-time adaptability of the lesson, the faculty preparation time required, the complexity of assessing the student, and the degree of learner autonomy.
Structuring the output as a matrix forces the AI to distill its semantic understanding into immediate actionable data.
The resulting table was a masterclass in clarity. For self-directed e-learning, the table highlighted that engagement was moderate, and the focus was largely on foundational knowledge. Scalability was extremely high, and faculty prep time was low.
Highly efficient, somewhat passive.
Right. Contrast that with case-based learning, which the AI noted offered high engagement, promoted critical thinking, but required moderate faculty preparation.
What about simulation?
For simulation-based training, the table showed very high engagement because it directly replicates real-world clinical scenarios. However, the matrix immediately illuminated the drawbacks. Simulation possesses massive faculty resource needs, low scalability, and highly complex assessment requirements.
Creates an instant dashboard for decision-making. You're a program director with only 2 available faculty members and a cohort of 150 students. You look at that scalability column and immediately realize that simulation-based training is mathematically impossible for this.
You pivot to case-based learning without having to read a 20-page white paper on instructional.
It bridges the gap between pedagogical theory and logistical reality. And it also pushes educators out of their comfort zones, where designing individual lessons, which the authors explored by mapping active learning strategies to specific objectives.
Yeah, they focused on a highly complex, notoriously difficult physiological topic, teaching first-year medical students about systolic and diastolic heart failure using pressure volume loops.
Okay, pressure volume loops.
They're the bane of many first-year medical students. They're intricate, graphical representations that plot pressure inside the left ventricle of the heart against the volume of blood during a single cardiac cycle.
Teaching how those graphs shift dynamically during different types of heart failure via traditional passive slide deck lecture almost universally results in poor student retention.
The faculty knew they needed an active learning method.
So they prompted the AI, they fed it the objective, specified that the environment was a small group setting, and asked for active learning strategies. And the AI didn't just offer one or two ideas, it generated 9 comprehensive, distinct instructional strategies.
The sheer volume of ideation is the value here. One of the strategies the AI detailed was concept mapping.
What did that do?
It suggested moving students away from their screens and having them work collaboratively on a large physical whiteboard. The prompts instructed the AI to provide the exact mechanics of the exercise. The AI suggested having the students visually draw and link key physiological determinants, stroke volume, preload, afterload, and myocardial contractility.
It told the faculty to make the students physically draw the connections, to visually map how an increase in afterload alters the shape of the pressure volume loop during systolic failure.
The AI even generated the pedagogical goal of the exercise, organizing complex ideas to explicitly illustrate the interconnectivity of factors of heart failure.
If you consider the standard operational run most professions fall into, this is a revelation. When humans are exhausted, faculty members are stretched thin between clinical duties and teaching. They default to the path of least resistance.
They open PowerPoint, they create 20 slides with bullet points, they talk at the students for an hour.
Right. And if you listening have ever had to present a quarterly report or a project update to your team, you know this exact pain. You are out of creative energy, so you just throw numbers on a slide and read them out loud.
But what the authors are demonstrating is that you can use an LLM as a creative sparring partner.
You can ask it to instantly generate 9 active, engaging, novel ways to present complex data, breaking out your cognitive.
The AI functions as a tireless ideation engine, but the authors temper this excitement with the necessary warning. An LLM generating 9 ideas does not mean it generated 9 feasible ideas.
Right.
The AI might suggest an active learning exercise that requires equipment the institution doesn't own, or a time frame that doesn't fit the block schedule. It generates the possibilities, but the human educator must provide the reality.
Which brings us directly into the collision with reality. We have built the map. We have designed a beautiful, engaging, progressive curriculum. But a curriculum on paper is useless if it cannot be executed.
Now we arrive at section 4, making it real.
Step 5, implementation. Moving from theoretical pedagogy to practical execution requires meticulous, exhaustive project management. Here, the AI reveals its utility as a hyper-organized administrative powerhouse.
The first barrier to implementation is often the educators themselves. The authors address this in their approach to mapping faculty development.
It is a profound, often overlooked insight. You can write the most brilliant modern curriculum in the world, but if your faculty does not possess the skills to teach it, the curriculum will fail on contact with the students.
You cannot simply write the phrase interprofessional collaboration into a syllabus and expect doctors, nurses, and hospital administrators to instantly seamlessly know how to co-teach a room full of students.
Exactly.
Educational literature routinely points out that systematic needs assessment are frequently missing from faculty development programs. Administrators tell faculty what to teach, rarely assess if they know how to teach it.
The authors utilize the AI to review their newly generated curriculum objectives to spot these exact human bottlenecks.
The AI analyzed the objectives and identified that the heavy reliance on systems-based practice and interprofessional collaboration meant the faculty themselves had a knowledge gap.
What was the solution?
The model suggested that before the curriculum could launch, the institution would need to run specific targeted workshops for the faculty on team-based communication dynamics and strategies for navigating complex, localized healthcare systems.
The AI anticipated the failure point. It proactively highlighted that the prerequisite to student learning is teacher training.
That capacity to extrapolate secondary logistical requirements is incredibly powerful, and the authors pushed that capability to its absolute limit when they tasked the AI with creating a comprehensive implementation checklist.
Oh, this part is amazing. They needed to design a 50-minute instructional session for medical students regarding best prompting practices and prompt engineering for healthcare applications.
Right.
They instructed the AI to adopt the persona of a faculty expert and generate an exhaustive implementation checklist aligned with the current 5th step.
The output generated from that single prompt was staggering in scope. The AI produced a massive 5-page, highly structured implementation guide.
5 pages for a 50-minute class.
I know. It bypassed simple administrative reminders like book a room or print the syllabus. It categorized the entire endeavor across multiple logistical domains. It provided technical organization, breaking tasks down into pre-session milestones, during session execution, and post-session follow-up.
It detailed the research requirements, built risk mitigation strategies, outlined the assessment plans, and established quality improvement processes for future iterations.
To understand the granularity, we have to look at the pre-session planning the AI generated 4 to 6 weeks prior to the class. It dictated securing a classroom, standard, but then instructed the faculty to verify that the room had adequate internet connectivity. It explicitly told them to test the bandwidth requirements to ensure 40 students accessing an LLM simultaneously wouldn't crash the network, and confirm that all students possess the correct institutional software license.
My absolute favorite part, it explicitly told the faculty to prepare offline, localized backups of the AI demonstrations.
Yes.
The model actively anticipated that the hospital Wi-Fi would likely crash during a live technology demonstration, and it built a contingency plan into the checklist. That level of logistical anticipation is wild.
It really is. The authors estimated that generating the single comprehensive document saved them 32 hours of faculty and administrative time.
32 hours is an entire work week reclaimed for a single individual. However, the authors are extremely transparent about the blind spots inherent in this process.
Right, because a 5-page checklist generated by an AI is comprehensively generic. It included several administrative elements that lacked any relevance to their specific program's operation.
And more critically, it completely missed the localized friction. The AI doesn't know that the projector in Lecture Hall B has had a color distortion issue since 2022.
It doesn't know that the IT department requires a minimum 3-week lead time to approve new software licenses.
It is entirely blind to the idiosyncratic nuances of institutional culture and infrastructure. The AI operates in a theoretical space where administrative processes work perfectly. The human operates in the messy reality of broken projectors and bureaucratic delays.
The core takeaway here is that AI is the ultimate generator of the 95% rough draft. It completely eliminates the terror of the plane.
It saves you 32 hours of racking your brain trying to remember every single logistical detail of a curriculum world. It offloads the mental burden of structural organization, preserving your cognitive energy so you can focus entirely on that final crucial 5%, the human localized nuance.
You let the machine build the scaffolding, and you apply the architectural finishing touches.
Which brings us to the ultimate reckoning of any educational endeavor. Section 5, did it work? This corresponds to Kern's step 6, evaluation.
We have assessed the needs, defined the objectives, chosen the instructional methods, and managed the implementation. But all of that is formative. We cannot empirically prove that the learner actually absorbed the required knowledge.
Evaluating medical knowledge is incredibly difficult, and it usually takes the form of the most universally despised task in all of academia: writing multiple choice questions or MCQs.
Oh, they're awful to write.
Anyone who's ever tried to write a good test question knows that it is agonizingly slow.
Okay.
You can't make it too easy. You can't make the wording confusing. And crucially, you have to test the student's ability to apply knowledge in a real scenario, not just test their ability to memorize flashcards.
Constructing a valid medical board style question is both an art and a highly rigorous science. You have to craft STEM clinical scenario, you have to write the lead-in question.
Right.
Then you have to generate the correct answer alongside plausible distractors, incorrect answers that are just accurate enough to catch a student who only possesses a superficial understanding of the topic. The authors utilized the AI to tackle this immense burden, focusing on preclinical methods.
They wanted to assess the student's knowledge of hemodynamic changes specifically, the pressures and flows of blood observed during the 4 different classes of physiological shock, as obtained by a right heart catheterization procedure.
But they didn't just ask for a question, they explicitly prompted the AI to align the generated question with taxonomy.
For context, Bloom's taxonomy is a foundational educational framework that classifies learning objectives into hierarchical levels of cognitive complexity.
At the very bottom is basic recall, simple memorization of facts. As you move up the pyramid, you reach understanding, applying, analyzing, evaluating, and finally, creating.
The authors did not want a bottom of the pyramid question. They didn't want the AI to ask, what is the definition of cardiogenic shock? They wanted a question that forced the student to live at the higher tiers of Bloom's taxonomy, to analyze data and apply theoretical knowledge to a single patient.
And the LLM delivered a highly sophisticated clinical vignette. It generated a scenario describing a 56-year-old male patient with a history of hypertension, hyperlipidemia, and a recent myocardial infarction or heart attack. The STEM detail that presents the emergency department exhibiting severe chest pain, dyspnea, and hypertension. The AI then provided a highly specific set of right heart catheterization measurements, including right atrial pressure, pulmonary artery pressure, and cardiac output.
It built an entire mathematically consistent patient profile. And the leading question asks, which of the following is the most likely diagnosis based on hemodynamic?
The correct answer generated by the model was cardiogenic shock due to acute myocardial infarction. But the true value of the AI's output wasn't just the question and the correct answer.
Distractors, right?
Yes. The model generated the plausible distractors, hypovolemic shock, distributive shock, etc., and it provided detailed paragraph-length explanations for why the correct answer was right, and exactly why every single incorrect option was physiologically wrong based on the provided categorization.
It didn't just write a test question. It generated a complete self-contained study and assessment package. The administrative impact of this is profound.
The authors reported that utilizing the LLM reduced the time required to write, format, and justify a single complex MCQ by 80%. Yes. When an educator is tasked with building a 100-question summative exam, an 80% reduction in generation time is nothing short of revolutionary.
The acceleration is uncommon. Here's the response. The stakes regarding evaluation are absolute. You are generating assessment materials concerning life-threatening medical conditions. If an AI hallucinates, if it accidentally swaps a normal pulmonary wedge pressure reading for an abnormal one in the vignette, and the faculty fails to catch it, you are actively teaching a medical student the exact wrong diagnostic criteria for heart failure.
It is a terrifying thought. The AI is highly confident, even when it is completely wrong.
Which is why the authors reiterate that human expert oversight is strictly, unequivocally required. The AI is drafting the clinical parameters. The intending physician must verify that the math aligns with physiological reality. The human is the final arbiter of truth.
And evaluation doesn't stop at the individual student level. To ensure the math is actually working, you have to evaluate the entire curriculum. You have to align your programmatic valuations.
The authors demonstrated this by trying to assess that notoriously difficult competency we discussed earlier, systems-based practice. Specifically, they wanted to evaluate if learners could successfully identify patient safety issues and implement quality improvement opportunities in the hospital system.
You cannot easily test systems-based practice with a multiple choice question. It requires a behavioral and observational assessment. Faculty use the AI not as a content generator, but as a brainstorming collaborator for structural design.
They prompted the AI to design a comprehensive framework for assessing this complex competency.
The AI responded by suggesting a multi-pronged systemic evaluation approach. It didn't rely on a single metric. It suggested 4 distinct methods of evaluation.
What was the first?
First, direct observation in real clinical settings, utilizing a checklist to see how learners actually respond to real-time safety concerns. Second, written assessments using complex case studies to evaluate their theoretical understanding of hospital protocols. Third, practical hands-on simulation scenarios to measure physical and communicative responses to engineered system failure. Finally, integration assessments requiring learners to present a quality improvement project to evaluate their ability to synthesize and apply knowledge across different operational content.
Furthermore, the model provided structural guidelines for how often these assessments should occur, what the baseline performance standard should be, how to structure remediation processes for students who fail, and what documentation the accreditation boards would require to prove the competency was met.
This single prompt saved the curriculum committee an estimated 4 hours of high-level brainstorming. It provided a comprehensive, defensible framework that they could immediately begin to tailor to their specific departmental capabilities.
So if we look back at the journey, we have successfully walked through the entire architectural blueprint, the initial needs assessment, all the way through to multi-level evaluation.
We have seen how prompt engineering using techniques like persona patterns, restricting context windows, and explicitly defining constraints can save weeks of administrative time.
We've seen AI generate novel active learning methods, build exhaustive implementation checklists, draft complex evaluations. The utility is honest.
The efficiency gains are paradigm shifting. The AI successfully manages the overwhelming complexity of the information. But
Yes. But we arrive at section 6, the final and arguably most vital part of this deep dive, the human element.
because despite all of this technological triumph, the authors of the study draw a very hard, unyielding philosophical line at the conclusion of their paper.
They pivot away from prompt engineering and focus entirely on responsibility, accountability, and moral agency.
It is the anchor of the entire study. The authors construct a core argument that must cover all AI integration. Responsibility and accountability are distinctly, exclusively human traits.
Right.
A large language model can map a curriculum with breathtaking speed. It can semantically cross-reference thousands of objectives. It can generate clinical vignettes and anticipate Wi-Fi failures. But it does not possess moral agency.
You cannot make a conscious decision based on intrinsic understanding of medical or emotional processes.
In medical education, this isn't a philosophical church. The stakes are literal life and death.
When a medical curriculum fails, when an accreditation standard is ignored, when a gap in the map is left unaddressed, or when a physiological concept is taught incorrectly because of AI hallucination, consequences do not stay inside the learning management system. They ripple out into the physical world. A real patient suffers the consequence of that administrative failure.
And it is the human educator who must bear the weight of that reality. Educators have to live with the legal, the professional, and the deep personal impacts of their choices.
When a student they train successfully navigates a trauma and saves a life, the educator experiences profound pride. And conversely, when the educational system fails a learner, and that learner subsequently fails the patient, the educator experiences profound remorse.
An algorithm cannot feel remorse. A neural network cannot feel pride. The machine does not and cannot contend with the downstream human consequences of its mathematical outputs.
But let me push back on this because I think this is where the culture shock actually originates. If we are integrating a system where the AI is doing 80% of the actual work, if the machine is writing the objectives, picking the teaching methods, generating the comparison matrices, and drafting the test questions, aren't we, by definition, slowly outsourcing our moral agency?
That's a fair concern.
Right. If an error slips through that AI's high sensitivity net, if a hallucinated test question gets approved because a fatigued professor trusted the machine too much, who is really to blame? Doesn't the tool's efficiency inherently dilute the human's accountability?
That is the exact trap the authors are warning against, and their answer is unequivocal. The blame falls entirely on the human. The human AI collaboration in education is fundamentally designed to enhance human cognitive capabilities, not to replace them. Outsourcing the tedious administrative mapping of a curriculum is an acceptable use of the technology. Outsourcing the final ethical judgment is a dereliction of professional duty.
Moving the faculty from AI resistance to AI acceptance does not mean teaching them to blindly trust the machine. It means requiring them to step up and assume the role of the ultimate ethical gatekeeper.
It is the analogy of being handed a high-powered tool after spending your entire career using a handsaw.
The power tool is exponentially faster, and it is vastly more efficient. But if you let your attention drift for even a second, that power tool will cause catastrophic damage much faster than the handsaw ever could.
Exactly. The sheer power of the technology demands them to be infinitely more responsible and more vigilant, not less.
The human educator's oversight now extends far beyond simply monitoring curricular alignment on a spreadsheet. It involves a deeply emotional and ethical commitment to the final outcome of the educational process.
The AI is a phenomenal technological collaborator. It facilitates the heavy lifting of the work. But the responsibility for what is taught, how it is taught, and the caliber of the position produced remains uniquely, heavily human.
Let's bring all of this together. We started with the incredibly painful, detail-oriented task of organizing human knowledge. We walked through Kern's 6-step model and witnessed how sophisticated AI prompt engineering can conquer administrative overload.
We saw how restricting an AI's creativity allows it to act as a flawless auditor, and how utilizing persona patterns can translate rigid bureaucracy into semantic meaning.
We observed the immense practical utility of AI in instructional design, alongside its very real inherent limitations. Its tendency to find non-existent red string connections, its complete blindness to localized institutional friction, and its total lack of moral agency.
Whether you are managing the architecture of a medical curriculum, designing a corporate training program, or simply trying to structure your own pursuit of complex knowledge, the central lesson of the University of Washington is clear.
Let the artificial intelligence do the heavy lifting of organization, cross-referencing, and drafting. Use the machine to cure the terror of the blank page, but you must remain the conscious architect of the final product.
You must bring your human expertise, your empathy, and your unyielding ethical judgment to the final edit. The machine provides the structure, but the human provides the meaning.
Which leaves me with one final provocative thought for you to consider as we wrap up. If we extrapolate the trajectory of this technology out over the next decade, if AI eventually reaches a point where it perfectly and instantly automates the entire logistical, administrative, and mapping burden of education,
If the what to teach and the how to teach are generated flawlessly in seconds,
exactly, then the fundamental role of the teacher is going to be forced into radical mutation.
how do you see that evolving?
Future educators will no longer be valued for their ability to organize information, or their skill at drafting supply, or their capacity to grade multiple choice questions. Those tasks will be effectively free and ubiquitous. Instead, educators will be valued purely and exclusively for their deep humanity. They will be prized for their empathy, their ethical guidance, and their unique ability to look a struggling student in the eye and help them navigate the crushing emotional weight holding a human life in their hands.
Wow. When the administrative mapping of knowledge becomes free and instantaneous, the authentic human connection becomes the ultimate, irreplaceable premium product of education.
The introduction of the ultimate artificial mind forces the educator to become more profoundly human.
Exactly. We started this deep dive talking about a map drawn on water, an overwhelming, constantly shifting landscape of information.
Artificial intelligence finally gives us the power to freeze that water, chart the territory instantly and perfectly. But a map, no matter how flawless, is still just a piece of paper. It still requires a human compass to decide which direction we actually ought to go.
And in this new landscape, that compass is.
Thanks for taking the deep dive with us. We'll catch you next time.
Learning objectives for this session are that we will be able to learn how AI can speed up teaching session design. We will know about Canva and presentation AI for PowerPoints and understand academic considerations. So we have current methods which we use, and we have different perspectives regarding their use. So how can we use AI to develop PowerPoint presentations? So there are different tools we can incorporate, including ChatGPT, Canva AI, Presentation AI, Gamma, Slides dot slidesai.io integration into PowerPoints. So AI for teaching outlines, ChatGPT. Prompts are important. There are some good strengths, but there are limitations that won't give you so much good, clear slides, and you need to validate what has been given in output. Presentation.ai uploads ChatGPT outline into presentation.ai and auto-generate structured slides instantly in presentation.ai. AI for presentation design, Canva AI hands-on exercise, and it generates a 5-slide deck on a chosen topic. It can add icons, visuals, and flowcharts. Integration. So from ChatGPT, you will generate teaching outline. From presentation.ai, you will auto-generate draft slides. And from Canva AI, you will polish design, visual, and infographics. So, AI tool. Almanac generate lesson plans with slides, worksheets, and tailored activities. QReport creates interactive lessons by typing a topic or uploading a document. In brisk teaching, there is turning of online resources into lessons, presentations, and engaging activities. In EduAid, there is a generation of lesson plan, activities, and assessment with over 150 AI powered tools. Canva AI is easy to use tool for creating visually rich presentations using Magic Design and Magic Write features. DIFFIT generates detailed educational resources, including customizable slides from topics or standards. Magic Slides AI platform offering tools to create PowerPoint slides from various sources like PDF, keywords, and YouTube videos. SlidesGo is an AI tool to generate editable presentation with customizable styles, tones, and slide counts. Beautiful.ai, AI-driven presentation tool that may help you design professional-looking slides with smart templates and automation. Slides AI, Google Slides add-on for creating AI-generated presentation and editable text and images. Sample presentation made by using Slide AI add-on in PowerPoint. You can see this has been generated and it looks so beautiful and so great. It is very colorful presentation. Unfortunately, there can be some irrelevant imaging in it, but you have to look for it. But it is a very beautiful and visually appealing presentation. As you can see, it has a lot of subsections mentioned as well, and it has even touched on to some very very advanced level topics of post-operative care, etc. And you can see that such a beautiful, visually appealing presentation can be created by the AI, and the students will like it very much and they will be involved in it. Similarly, another presentation on septic shock, as you can see, the visuals and the all the important topic areas being touched, and meanwhile, relevant visuals are given. Sometimes they may not give a great data exactly, but you have to look for the pictures, and still it is visually extremely appealing and very different from the routine that we use for creating visually appealing presentations. These are so beautifully constructed PowerPoint presentations using the AI. You can see how the another presentation and so on and so forth. So AI can help you create very visually appealing presentations that will attract the student, and the student will like it, and you will be able to engage your audience with a very highly colorful and engaging presentation. This one is on measles. You can see how much beautifully depicted. Every single word is a picture along with a short uh, narration of the problem. So it is extremely good to use them, and presentations can be made with AI. They would be enormously impactful. Thank you. These are our learning objectives for the session. And now we move directly to the session. So AI is reshaping traditional assessment methods in transformative ways. Educators and learners are turning towards AI to enhance objectivity and effectiveness of assessment processes. Integrating AI into assessment holds the promise of a more personalized and adaptive approach to evaluating individuals. So, designing MCQs, essay type questions, and OSCEs using different AI tools. Developing MCQs that align with the educational goal requires a deep understanding of subject matter as well as awareness of the potential pitfalls associated with poorly constructed MCQs. So, if we give one prompt into ChatGPT, it will start doing the work for us. But we will have to use the same Bloom taxonomy: C1 remembering, C2 understanding, C3 applying, C4 analyzing, C5 evaluating, and C6 creating. And MCQ prompt on, for example, acute abdomen. For C1, you will develop an MCQ asking student to recall the key sign and symptoms of acute appendicitis. In understanding level, you will modify, develop a MCQ that requires student to explain the difference between visceral and somatic abdominal pain and acute abdomen. In applying C3 level, develop MCQ asking student to apply their knowledge by choosing the most appropriate diagnostic test for a patient presenting with right lower quadrant pain and suspected appendicitis. In C4 analysis level, you will give the prompt, develop MCQ that requires students to analyze a clinical case with symptoms of acute abdomen and determine which organ system is most likely affected based on the pattern of symptoms. In evaluating C5, you will give prompt as develop an MCQ asking student to evaluate different management options for a patient with acute cholecystitis and select the best treatment based on current guidelines. In creating C6, develop an MCQ encouraging student to design a management plan for a patient with acute abdomen caused by perforated peptic ulcer, justifying their choice based on clinical evidence. So these are the different ways to give prompts for different levels of Bloom taxonomy, which we are all already familiar with the Bloom taxonomy. So you go to Socrative.com and create an account while you are creating MCQs. And there are common technical item flaws like test wiseness, grammatical cues, logical cues, word repeats, longest option is always correct, absolute terms, implausible distractors, convergence, all of the above and none of the above are test wiseness like things, and often students lead to the right answer by using these clues. Irrelevant difficulty is by vague terms, poor sequence in the numerical data, unnecessary information, unclear or ambiguous information, and more than one or no correct answer, and it may fail the hand cover test, and it may have negatives not except in the term. Negatives other than except one may be there as well. So these are the different problems with item construction. Other than Socrative, Google Forms can be used as a quick quiz app. Quizlet.com is another one, but most features are behind paywall. Turnitin can auto-grade as well. Short answer question with marking key prompt. Develop a short answer question that requires students to apply their knowledge of the diagnosis and initial management of patient presenting with acute abdomen. Ensure the question includes the clinical scenario and ask the student to justify their management decision based on clinical evidence. Also provide a marking grade. So this is the prompt for a SAQ with marking key. It is the standard prompt. For OSCE, the standard prompt is different. Design an objective structured clinical examination station that requires students to obtain informed consent from a patient diagnosed with gallstones who require a cholecystectomy. Ensure the OSCE involves communication skill, explanation of procedure, potential risk, and addressing patient concerns. Also include marking sheet instruction for the candidate examiner and simulated patient. So these are the references from where this was taken, and that is all about creating assessment. And this is the beautiful picture of our Khyber Medical University where all the knowledge flows. Learning objectives are fourfold: to understand the foundation of education and digital context, examine integration of AI in education, develop competencies in digital literacies and AI ethics, and analyze real-world AI implementations in education. Before thinking about how you might use AI in your classroom, it is important to refresh your thinking about what is you are aiming to achieve. Your aim should be clear with it. What is education? It is easy to be seduced into using innovative technologies which have the appearance of being helpful insofar as they allow learners to present work that seems to be of a high standard. As you will appreciate, a product is only meaningful if it is authentic evidence of learning. Education is a multifaceted concept that varies depending on the context, such as teaching children versus adults. UNESCO 1996 Learning the Treasure Within defines education as encompassing four fundamental types: learning to know, learning to do, learning to live together, and learning to be. While the process of education can be challenging, its ultimate outcomes are rewarding and beneficial. If we take, for example, the process of learning to read and write, we can easily see how tempting it must be for a learner struggling to shape letters and from them form them into words on a paper. To prod a machine to produce a piece of elegant script in a typeface of their choice. But again, we can learn from Aristotle. We learn an art or craft by doing the things we shall have to do when we have learned it. This is often quoted as what we have to learn to do. We learn by doing. So, considerations to educating in a digitalized world. SAMR model, a framework to gauge the integration of digital technologies into education. Levels of SAMR model: substitution, augmentation, modification, redefinition. Purpose of SAMR model: to help educators consider the role of digital technologies in teaching and learning and its impact on learning activities. SAMR: substitution, augmentation, modification, and redefinition. A reflective tool to consider technology roles in teaching. SAMR: substitution: technology substitute another tool. There is no functional change to the activity. Augmentation: technology substitute another tool. There is a functional improvement to the activity. Modification: the incorporation of technologies allow for a significant redesign of the activity. And redefinition: the incorporation of technologies allow for the creation of new activities that were previously inconceivable. Bloom's taxonomy: evolving learning objectives and outcomes in 1956 versus Anderson 2001. So knowledge comprehension, application, analysis, synthesis, evaluation by Bloom. To remember, understand, apply, analyze, evaluate, and create by Anderson and Krathwohl in 2001. Bloom was, and as remember, Bloom was interested in his own levels by giving the 6 levels of remembering, recall facts and basic concepts, understand, explain ideas or concepts, apply, use information in new situations, analyze, draw connections among ideas, evaluate, justify a standard decision, and create, produce new or original work. This was the 6th level of Bloom's taxonomy. Digital citizen. Who is a digital citizen? Digital citizens, the digital competence framework for citizens in 2022. Information and data literacy: locating, accessing, searching, filtering, managing, storing, and evaluating information and digital content. Collaboration and communication: interacting, sharing, engaging in citizenship, collaborating through digital technologies, managing digital identities, digital content creation, like developing, integrating, re elaborating digital content, copyright and licenses, programming, safety, protecting devices, personal data, privacy, health and well-being, and the environment, problem solving, solving mechanical problems, identifying needs, creative use of technology and responses, and competence gaps. Other digital competence and skill frameworks, ISTE standard, empowered learner, digital citizen, knowledge construction, innovative design, computational thinker, creative communicator, and global collaborator. There is another digital proficiency and productivity design in which digital creation, problem solving, and innovation, digital learning and development, digital identity and well being, information data and media literacies, digital communication, collaboration, and participation. Growing need for AI literacies and competence development, confidence and ability to clearly explain how AI technologies work and impact society. Use them in an ethical and responsible manner. Effective communication and collaboration with them in any setting. Confidence and ability to self reflect on their AI understanding. Reflect on how well individuals use AI in beneficial ways. The importance of pedagogical choices sharps, sharpens your knowledge, but you have to have your pedagogical choices that shape the success of AI in your classroom. Effective integration of AI depends more on your teaching methods than on the digital tools. We will explore different pedagogical approaches impact on the use of AI in teaching. The success of AI tools depend on how structure and facilitate learning. Your role is key in integrating AI into models like flipped classroom, AI deliver lectures and quizzes at home, teacher facilitate engaging in classroom or practical activities. Project-based learning. AI aids the research and data analysis, but success relies on the teacher ability to guide inquiry and collaboration. Play-based learning. AI tools create interactive games for young learners. Teachers must nurture a stimulating environment. Blended learning. AI supports online and in-person activities, but teachers ensure seamless integration and provide personalized. What is AI-driven teaching practice? Your pedagogical choices define the success of your teaching. AI tools offer support, but your decision in structuring learning and engagement make the difference. Example, intelligent learning tutors AI powered are valuable but must be integrated into broader strategies. Critical thinking in integration, evaluate AI recommendations, ensure they align with educational goals, adapt AI generated content, customize it to fit your classroom unique context, reflect and iterate continuously, assess AI effectiveness and make adjustments as needed. Interactive content, AI boosts engagement with dynamic learning materials, speech recognition, real-time conversations help students practice language or problem-solving skills. Group collaboration are AI tools organize roles and discussions promoting structured teamwork. So personalized learning with AI, adaptive learning, AI adjusts tasks based on student performance, personalized feedback, AI provides real-time feedback, enhancing student understanding, learning analytics, AI help identify learning patterns to offer tailored intervention. So AI can't replace the emotional intelligence, creativity, or personal interaction that teachers provide. Teachers nurture critical thinking, empathy, and personal growth that are irreplaceable qualities. If, let's examine AI implementation in different educational contexts and reflect whether technologies create new opportunities or more barriers for students and educators. Case study 1 in Spain. AI tool helped me see challenge visually impaired students struggled with navigation and accessing material. AI powered app using computer vision and machine learning to recognize and narrate objects, text, and other elements. Impact increased student independence and confidence, enhanced engagement in academic and second case study is Math pathway of AI tool with large class size hindered personalized STEM support and engagement of students. AI-driven platform personalized math education based on each student pace and learning style, continuously assessed student progress and powered real-time feedback. Significant improvement in math performance with higher engagement, better test scores, and more effective intervention for teachers. Another case study is physical education and AI. Traditional physical education classes did not meet the varied fitness levels of students, so AI system collected fitness data from different devices, customized workout plan, tracked students' progress over time, and it had impact on personalized fitness plans, improved motivation and participation, and teachers could monitor and adjust workout based on the data. So step one, how you can create a PLP using AI hands-on. First, you will define your learning goals. Second, you will start by identifying your current knowledge level, and then you will create your own personalized learning through step three, specifying your learning preferences. And step four, you will give time frame and availability. And step five, you will just choose assessment methods. And step six, you will request additional resources. Here is an example prompt. And step seven is define challenges and barriers. And step eight is customize and generate the pathway. Example prompt has been given as well for the same. And other examples are adaptive learning platforms like Dreambox or KNEWTON using AI to personalize learning, AI powered learning management systems, Moodle and Canvas provide AI powered analytics and content recommendation. AI chatbots like IBM Watson Assistant and Microsoft's Bot framework can be used to create AI powered tutors and virtual assistant. AI based content creation tools like OpenAI GPT for content summarization and personalized content creation. Now we will hear what a running commentary on this same topic says. Listen.
So just struggling to write an essay, right? And they can sit there and syntax, data school, the large language model generate paths, structural perfection, like 3 seconds.
3 seconds, exactly.
Yeah. And if we choose one, and let's face it, a lot of people are doing what exactly is happening to the neural pathway, right? Are we freeing them up to think about bigger things, or are we quietly outsourcing the very required activity? What will cutting edge artificial.
It really is the defining collision of our era, isn't it?
Absolutely.
And to look at it properly, we really have to move past this idea that artificial intelligence is just like a really fast search engine or an upgraded calculator.
Right.
A much better way to think about AI, at least in the context of learning, is as a cognitive exoskeleton.
Like that. And exoskeleton.
Yeah, think about it. A physical exoskeleton allows you to lift thoughts without straining muscles, which, is great for efficiency. But if you wear it every single day, your actual biological muscles will eventually atrophy.
Because they aren't getting any resistance.
Exactly, because they're no longer experiencing that resistance. So today, we're exploring this deeply insightful presentation. It's titled AI to an by Dr. Syed Mohammed Junaid.
Yeah, it's a fascinating document.
It is. And our mission today is to move way beyond surface level panic or superficial hype about cooling software. We're looking at how to use this cognitive exoskeleton to actually elevate human critical thinking rather than just letting our intellectual muscles display.
Yeah, the stakes really could be higher. We're going to zoom all the way out to high-level pedagogy, examining the foundational theories of how human beings actually acquire knowledge. And then we'll zoom into the molecular level, looking at really specific real-world case studies from across the globe.
Which is super interesting.
They really are. And finally, we'll give you a practical playbook for how to use this technology. But to understand how to integrate this technology, work with your actually forces us to take a massive step back. It forces us to ask a deceptively simple question. What actually is education?
Right, good question.
Yeah. And it points us to this foundational document published back in 1996, beautifully titled Learning, Treasure Within.
1996 was a really fascinating year to anchor this discussion.
Because of the internet.
Exactly.
Yeah.
The internet was just beginning to enter the public consciousness. We're right on the precipice of the information age. And yet, the philosophers and educators authoring that UNESCO report, they somehow recognized that simply having access to information would not be enough.
Wow. Very impressive.
They define education not as the mere transmission of facts, but as a lifelong process supported by 4 distinct pillars. They are learning to know, learning to do, learning to live together, and learning to do.
Okay, let's spend some time unpacking those 4 pillars because they really do serve as the ultimate litmus test for everything we're going to discuss. So, learning to know, that's probably what most of us think of when we picture a traditional school. Right?
Yeah, classic classroom model.
Right. It's the acquisition of the instruments of understanding, yes, the mastery of facts, memorization of multiplication tables, understanding the water cycle. It is the raw data of the world.
But of course, data without application is it doesn't do anything.
Right.
And that is what second pillar learning to do. This is the ability to act creatively on your environment. So it's taking the mechanical knowledge of physics and actually building a bridge that doesn't collapse.
Putting the theory in practice.
Exactly, the application of theory into practice. And for a long time, traditional education heavily prioritized these first 2 pillars, mostly because they are the easiest to measure with a standardized test.
That makes total sense. But the 3rd and 4th pillars are where things get profoundly human. So learning to live together. That's about participating and cooperating with other people in all human activities. So we're talking empathy, conflict resolution, understanding diverse perspectives.
Yes, the social fabric of learning.
Exactly. And then the 4th pillar, learning to be, is essentially the ultimate goal of the entire enterprise. It's the development of your own personality, your autonomy, your judgment, your personal responsibility. It's the realization of your full human potential.
And when we view education through the lens of those 4 pillars, the threat and the promise of artificial intelligence come into incredibly sharp focus.
How so?
Well, Dr. Junaid's presentation highlights a major psychological trap that we are all very vulnerable to right now. He calls it the seduction of innovative technologies.
Oh, that's a great phrase.
It's incredibly easy to be seduced by a tool that allows a learner to present work that appears to be of astonishingly high standard. But, and this is the key, a polished product is only meaningful if it is authentic evidence of learning.
Right. And the presentation grounds this entirely in a quote from Aristotle, which I love. The quote is, "We learn an art or craft by doing the things we shall have to do when we have learned it."
Learning by doing.
Essentially, yes. The act of doing the thing is the mechanism of learning the thing. And the source actually contrasts Aristotle's ancient wisdom with a very modern, almost tragic scenario.
The handwriting example.
Yes. Think about a young learner physically struggling to write letters on a piece of paper. They're awkwardly gripping the pencil. They're trying to remember which way the curve of the V goes. They're getting frustrated, and their handwriting is super messy.
We've all been there.
Right. It's a slow, agonizing process. But right next to them is a machine. They can prod a keyboard a few times, and the screen instantly produces an elegant, perfectly formatted piece of script.
And the seduction there is just overwhelming. I mean, why on earth would we subject a child to the frustration of a messy paper when the machine can produce perfection in a microsecond? But if we look at the neurobiology of what is actually happening there, skipping the physical struggle means skipping the cognitive rewiring that occurs during that struggle. The physical act of shaping those letters, the visual feedback of getting it wrong and erasing it, the immense mental effort required to translate an abstract thought into a physical fine motor movement, that messy, frustrating process actually is the education.
Okay, I want to push back on that idea just a bit. Acting on behalf of the listener who is maybe thinking about absolute efficiency. Because if a machine can do it instantly, aren't we just saving the learner time?
That's the con argument, yeah.
Right. We don't force engineering students to use a physical slide rule instead of a digital calculator just for those supposed struggle on it. So if an AI can write a beautifully structured essay outline in 2 seconds, aren't we just freeing that student up to think about much higher level, more important concepts?
See, the slide rule is the perfect counter argument. And it's actually the exact debate happening in educational policy circles globally right now. But we have to look really closely at the mechanism of the tool itself. A calculator computes, right? It does not comprehend. When you use a calculator to find the square root of a massive number, you are outsourcing real computation. Exactly. But when you use an artificial intelligence to bypass the foundational steps of constructing an argument, evaluating evidence, or wrestling with syntax, you are not merely saving time, you are outsourcing the cognitive flow required to build foundational neural pathways of critical thought. So when Aristotle says we learn by doing, the underlying truth is that the doing actually changes us internally.
It changes the brain.
Right. If you just prompt the machine to produce the elegant script, you walk away possessing a nice looking document, but you have not gained the art or the craft. Your brain has not changed.
You essentially own the output, but you skip the input.
Exactly.
And that brings up a massive structural problem for society. Because authentic learning requires the friction of doing. How on earth do we measure if a piece of technology is actually helping us do better, or if it's just secretly doing the work for us?
Yeah.
Because the genie is out of the bottle.
Yeah.
We clearly aren't going to throw the computers out the window and go back to Quill and parchment.
No, we definitely are. And that is the pivotal challenge right there. We need robust analytical frameworks to evaluate our use of technology.
Right.
We can't just operate on vibes or assume that because the screen is glowing, learning is automatically happening.
We've all seen a glowing screen where absolutely zero learning was taking place.
Exactly. And the source material provides two incredibly vital frameworks for navigating this digitized educational landscape. They are the SAMR model and Bloom's digital taxonomy. Let's dig into the SAM model first, because it specifically evaluates the technology itself.
Okay, so SAM is an acronym, right? SAM.
Yes.
It stands for substitution, augmentation, modification, and redefinition. It's basically a reflective tool designed to gauge the depth and authenticity of digital integration in any learning environment.
Think of SAM as a ladder. It moves from mere mechanical enhancement at the bottom to total social transformation at the top.
Okay, let's climb the ladder.
So at the very base level, you have substitution. This is where the technology acts as a direct substitute for a previous, but absolutely no functional change.
So an example would be,
Imagine a teacher who used to hand out a worksheet. Now they upload PDF of that exact same worksheet to the digital portal, and the student types their answers instead of writing them with a pen.
okay, so medium is changed from paper to pixels, but the cognitive task is identical.
Precisely, that's substitution.
Okay, so we step one rung on the ladder to augmentation.
Right.
Here, the technology is still acting as a direct tool substitute, but now there's actual functional improvement. So let's stick with the reading side. Okay? Instead of just reading a static PDF, the student is reading the text on a platform that has a built-in dictionary. If they highlight a word, the definition pops up immediately. Or perhaps there's a text-to-speech functionality that reads the text aloud for a student with dyslexia. So the fundamental task reading and answering questions is the same, but the technology has significantly augmented the learner's ability to engage.
Perfect example. Now, those first two levels, substitution and augmentation, are generally considered enhancement. But when we move to the next level, modification, we cross a really critical threshold. Exactly. We move from enhancing the task to actively transforming it. The incorporation of technology now allows for a significant redesign of the activity itself.
How so? Give me an example of modification.
Okay, let's say the original assignment was to write a solitary book report. Under modification, the student writes the report on a shared cloud-based document. Their peers and their teacher can leave real-time audio notes. They can suggest edits simultaneously and embed multimedia links directly into the text.
Oh, wow. So the assignment is no longer just a solitary static product.
Right. It is a dynamic, collaborative process. The technology has fundamentally modified the nature of the work.
And finally, we reach the absolute pinnacle of the ladder, definition.
Top down.
This is where the technology allows for the creation of new tasks that were previously entirely inconceivable without it. So the assignment is no longer a book report at all.
What is it instead?
Instead, the students use AI to analyze the thematic structure of the novel. They collaborate via video link with a classroom on other content to study the exact same book. And together they co-create a dynamic, interactive digital museum exhibit exploring the novel's historical context, complete with AI-generated audio tours.
Wow. Yes. Redefinition is the goal because it leverages technology to create experiences that deeply embed the learning. SAMR really forces everyone, teachers, managers, parents, to ask a hard question.
Which is,
Are we just using a $1,000 piece of glass in Silicon to do exactly what we used to do with a TV? Or are we redefining the boundaries of what is possible?
that's a great question.
But here's the catch. SAMR only measures the capability of the technology. It does not measure what is actually happening inside the architecture. Right.
So to pair the mind, the source pairs SAMR with a digital update to Bloom's taxonomy. This was developed by Andrew True.
Yes. Now, anyone who has taken an education or psychology class is definitely familiar with Bloom's taxonomy. It's been around since 1956.
Right, the classic pyramid.
Exactly. It's used to categorize education goals, moving from lower order thinking skills at the bottom to higher order thinking skills at the top. But Church's 2006 update is brilliant because it maps specific digital verbs onto this psychological pyramid.
Let's construct the pyramid from the ground up so we can visualize this. At the foundational base, the absolute lowest order of cognitive effort, we have remembering.
Right.
In the digital era, what does remembering look like? The verbs are bookmarking a web page, highlighting text on a tablet, listing bullet points, or saving the file to a folder. It's basically default and data.
Very low cognitive load.
Exactly. Then, as we move up one level, we hit understanding. The cognitive load increases slightly. The digital verbs here look like annotating a document with your own thoughts, or summarizing a long article using a mind map.
We're comparing two different websites.
Yes, or explaining concepts on a digital forum. You aren't just saving the data anymore, you're actually making sense of it.
Then we cross into active utilization with the next level, applying.
Okay.
This involves implementing, running digital simulations, uploading content to a specific platform, or sharing resources within a network. Crucially, source material places the actual prompt, like writing a prompt for an AI in this category.
Oh, that's interesting. So prompting isn't creating, it's applying.
Right. You are applying your understanding of a goal to manipulate a system to achieve a result.
Okay, now we cross the real threshold into higher order thinking. Next level up is analyzing. This is where real intellectual activity lives.
Yes, it is.
The digital verbs here involve deconstructing media, interrogating large data sets, organizing disparate pieces of digital information, and finding hidden patterns using analytical tools. You are actively breaking the information down to understand its component parts.
And right above that is evaluating. This is a highly sophisticated cognitive state. It involves critiquing a source of bias, reviewing digital content, judging the validity of an AI-generated response, which is right now, testing software, defending an argument in a complex online debate, and validating data.
You are making informed judgments based on strict criteria.
Exactly.
And sitting at the very peak of the pyramid, the highest order of human.
For the ultimate goal.
The digital verbs here are designing an interface, constructing a virtual environment, planning a digital campaign, inventing a new workflow, programming a piece of software, producing a podcast, or blogging original thoughts. You're synthesizing everything below to produce entirely new original work.
And the profound insight of the source material is how these two frameworks, SAMR and Bloom's digital taxonomy, absolutely must interact.
They can't exist in a vacuum.
Right, because you can have the most advanced technology in the world operating at the redefinition level of SAMR. But if the student is only using it to bookmark websites, they are stuck at the remembering level of things. They are using a supercomputer to do lower order thinking.
I love the visual of how these two interact. To me, it's like a high performance vehicle.
Okay, let's hear it.
The SAMA model is the engine of the technology.
Yeah.
It dictates how much raw horsepower and capability you have at your disposal. But Bloom's digital taxonomy is the steering wheel and the roadmap inside the student brain. You can have a massive redefinition level engine under the hood, but if the student is only using it for lower order recall, they're just driving the Formula One car in circles in the parking lot.
Driving in circles, that is perfectly put.
You need both. You need transformative technology paired with pedagogical design that literally forces the student to steer toward higher order creation and evaluation.
That analogy perfectly illustrates the poor tension we're facing. And this brings us to a rather uncomfortable societal realization.
Uncomfortable now.
Well, there's a deeply ingrained assumption out there that because young people today have grown up completely immersed in this high horsepower technology, because they have never known a world without ubiquitous Wi-Fi, smartphones, algorithmic feeds, that they automatically know how to swim on.
We assume they naturally operate at the top of Bloom's pyramid simply by virtue of their age.
Exactly. The thing is digital native.
Right. We hear that phrase constantly. The idea that kids are just naturally fluent in technology in a way older generations are.
But the source material throws a massive bucket of cold water on that idea. It explicitly highlights what it calls the digital native myth, citing research by Princeton in 2010.
The digital native myth.
Yes. The myth of the digital native is honestly one of the most dangerous assumptions in modern education. The assumption is that youth equals digital literacy.
It doesn't.
Not at all. As the text clearly defines, utilizing digital technologies or possessing mechanical technical skills is not the same thing as being literate. Knowing how to quickly edit a video on a smartphone or navigate a complex video game interface, those are mechanical skills. They are user interface tools.
Right. Muscle memory almost.
Exactly. They do not equate to a deep critical understanding of the digital environment.
Let's ground this in reality because anyone observing a teenager on social media can see this.
Oh, absolutely.
Just because a 14-year-old can seamlessly stitch together a viral video in 30 seconds using just their thumbs does not mean they have the slightest understanding of how the platform's recommendation algorithm is profiling their psychological vulnerabilities to serve them targeted advertising.
Right. It's a completely different skill set.
The source references Tim Huffington, 2022, which defines digital literacy not as a mechanical skill, but as a deeply developed set of competencies and critical thinking skills required for safely and effectively navigating the digital world.
And to map this out, the source relies on the European Union's DIGCOM 2.2 framework.
The EU DIGCOM 2.2 framework is incredibly rigorous. It defines a digital citizen across 5 distinct pillars, and none of them zero are about how bad they can type.
Let's explore these pillars because they really show the vast gulf between a digital consumer and actual digital citizen.
So the first pillar is information and data literacy. This goes far beyond just typing a question into a search engine.
It's about evaluation. Exactly. It is the ability to locate, access, filter, and critically evaluate information. If a student sees a deeply convincing video of a politician saying something controversial, do they have the literacy to trace the provenance of that video? Can they analyze the metadata? Can they evaluate the credibility of the host?
Wow, that's rigorous. Okay, the second pillar is collaboration and communication. This means interacting, sharing, engaging in civic life through digital technologies. Crucially, it also includes managing digital identities and etiquette.
Etiquette is so important.
Right. It's the understanding that the way you communicate in an ephemeral messaging app with your friends is fundamentally different from how you present your digital identity in a professional or academic forum. It is the active awareness of your digital shadow.
And then the third pillar is digital content creation. This involves developing and integrating new content, but it is heavily focused on the ethics of creation.
Ethics like what?
Like, does the learner understand copyright law? Do they understand open source license? Do they understand the foundational logic of programming, even if they aren't software engineers?
It's about respecting the ecosystem.
Exactly.
Okay, the fourth pillar is safety. And this goes way beyond just having a task or updating your antivirus software.
Which is what everyone thinks of.
Right. It's about protecting personal data and privacy, sure. But it also explicitly includes protecting physical, psychological health, well-being, and even understanding the environmental impact of digital technologies.
Yes. Knowing what to screen down because it is actively inducing anxiety is a core component of digital literacy.
That is profound. And the final pillar is problem solving. This is the ability to identify technical needs, make creative use of technology to solve conceptual problems, and perhaps most importantly, recognizing one's own competence.
Yes. A truly literate digital citizen knows exactly what they do not know, and they know how to systematically seek out that missing knowledge.
Now, that framework was already a massive challenge to teach. I mean, that's a lot. But when we superimpose generative artificial intelligence over that landscape, the difficulty multiplies exponentially.
It really does.
The source material points to a rapidly growing need for specific AI literacy, researched by Chiwakata in 2024. And these literacies are fascinating because they aren't about coding at all, they're about cognition.
Let's dissect these specific AI literacies because they really represent the new frontier of education. The first AI literacy is having the confidence and the ability to clearly explain how AI technologies actually work, how they can impact society. You don't need to be a machine learning engineer, but you must conceptually understand the black box. You need to understand that an LLM is predicting the next statistically likely word based on fast training, not pulling objective truth.
Right, it's not important. The second AI literacy is the ability to use these tools in an ethical and responsible manner. So this means understanding issues of plagiarism, intellectual property, and honestly, cost, the massive server farm required to run this.
The energy cost.
It is. Third is the ability to effectively communicate and collaborate with AI systems in varied settings, treating them as dynamic tools rather than infallible guides.
But it is the fourth AI literacy that is the most critical and probably the most difficult to achieve.
What's the fourth?
It is the confidence and ability to self-reflect on your own AI understanding and to reflect on how well individuals and society are using AI in beneficial ways.
So it's a metacognitive skill.
Exactly. It requires a learner to constantly evaluate their own relationship with machine.
That requirement for self-reflection is profound. Let's make this highly personal for everyone listening.
Okay, let's do it.
You might be incredibly adept at opening an AI chatbot and typing in, "I have chicken, broccoli, and rice in my fridge. Give me a highly rated dinner recipe." The AI spits out a beautiful recipe in seconds.
Tinker is safe.
Right. So you possess the mechanical skill from the machine, but do you have the AI literacy to self-reflect on that interaction?
Right. Do you know how the algorithm weighed the data set to decide which specific flavor profile to suggest?
Exactly. Do you know if it is suddenly prioritizing branded ingredients because of hidden affiliate marketing data embedded in its training set?
Do you know which corporate entity now owns the data of what you just told it about your dietary habits and how they might sell that?
Exactly. Blind trust in an algorithmic output is the absolute opposite of educated mind.
It is the ultimate abdication of intellectual responsibility. And because students, regardless of how many hours spent on TikTok or playing Roblox, are not naturally born with these deep critical evaluation skills, the digital native myth is actively dangerous.
It gives society a false sense of security.
It allows us to abdicate our responsibility to teach them. The burden of building these literacies falls squarely on the intentional design of the educational environment.
Which transitions us perfectly to the core operational question.
Yeah.
If the teacher has to build this complex philosophical AI literacy, how do they actually design a physical or digital classroom to do it? Right? This is really the central thesis of the entire source document. Pedagogy first. The architect of the AI classroom is the human teacher.
The presentation could not be more explicit on this. It states, in bold terms, your pedagogical choices shape the success of AI in the classroom.
It's all about pedagogy.
The success of the integration is not determined by the budget you spend on software licenses. Effective integration depends almost entirely on the teaching methods. Technology is subservient to it.
And the source outlines how this subservient AI fits into several highly specific modern pedagogical models. Let's examine the flipped classroom model first, because AI really supercharges this concept.
Okay.
So in a traditional 20th century classroom, the teacher uses valuable in-person time to broadcast the lecture, and the student goes home to struggle through the homework alone.
The classic model.
Right. The flipped model reverses this. The student absorbs the lecture at home and does the homework in class where the teacher can actually help.
And with AI, this becomes incredibly potent. AI-driven platforms can deliver the lecture at home, adapting video speed, pausing for micro quizzes, and repeating concepts based on the individual student's real-time comprehension.
And think about what that does to the physical classroom the next morning.
Exactly. When the students arrive, the teacher already has a dashboard showing exactly which concepts the students struggled with the night before.
So the teacher is no longer wasting an hour lecture into a room where half the kids are bored and half are lost.
Instead, they facilitate highly engaging, deep dive activities, debates, and collaborative problem solving based directly on the data.
That is brilliant. Then we have project-based learning. In this model, students tackle complex, open-ended, real-world problems. Let's say a high school class is tasked with designing a sustainable urban water system for their city. AI can operate as the ultimate research assistant in the background. It can crunch vast amounts of topographical data, run fluid dynamic simulations, and summarize municipal zoning laws.
But the success of the project relies entirely on the teacher's ability to guide human inquiry.
Yes. The teacher manages the collaboration, pushes the students to question the AI's data, and forces them to weigh the ethical and economic impact of their design on different neighborhoods. The AI simulates the physics. The teacher guides the humanity.
I love that phrase. The AI simulates the physics, the teacher guides the humanity. We see a totally different application in play-based learning, which is crucial for early childhood development.
How does AI?
AI tools can create highly interactive adaptive games that respond to a young child, fostering curiosity and exploration. But a tablet is just a cool piece of glass.
Right.
The learning only crystallizes if human teachers present to nurture a stimulating, emotionally safe environment around that game. The teacher helps the child process the frustration of losing, celebrate the creative solution, and connect the digital game to the physical world around it.
And finally, there's blended learning, which is the deliberate orchestration of online and offline activities. AI is brilliant at bridging this gap.
It really is.
It can provide a seamless transition between a digital spelling test and a physical reading group. But it's the human teacher who interprets the analytics to ensure the blend is actually working, providing personalized empathetic support the moment the data shows a student's engagement drop.
And to manage all of this without becoming completely overwhelmed, the source provides a critical operational framework for educators. It's a continuous cycle for critical thinking and AI integration.
Okay, what is this?
It consists of 3 rigorous steps: evaluate, adapt, reflect, iterate. First, response. You never blindly accept AI's lesson plan replication. You critically evaluate the output to ensure it actively aligns with your true underlying educational goals. The text cites Bender and Collar from 2020 on the absolute necessity of this alignment.
Right, checking the alignment. Second, you adapt. Raw AI content is usually pretty generic. The teacher must adapt and customize that generated content to fit the specific cultural context, the emotional maturity, and the unique neurodiversity of the actual needs in the classroom.
Because an AI doesn't know your
Exactly. And AI doesn't know that half your class was traumatized by a local flood last week. The teacher knows that and adapts the lesson on literacy supporting.
And third, you reflect and iterate. You treat every AI integration as an experiment. You constantly assess if the AI's involvement actually produced authentic learning, and if it did, you iterate and change the approach.
I want to address the elephant in the room regarding all this pedagogical design.
Yeah.
Because a very valid fear among educators is that this entire process simply turns teachers into high-level IT managers.
Yes, I hear this fear all the time.
The fear is that the teacher will end up just sitting at a dashboard, staring at analytics, managing software subscriptions, and resetting passwords while the algorithms do the actual teaching.
Right.
The AI is delivering the lecture, grading the quiz, pacing the homework, and running simulations. what does the teacher actually do? Are they just a chaperone in this group?
The reality, when executed correctly, is the exact opposite.
Oh, really?
Yes, this technological integration elevates the teacher. It forces them to move to being a highly interactive, empathetic facilitator. The text specifically highlights intelligent learning tutors. These are AI-powered systems that provide personalized, real-time feedback and adapt to a student's micro-performance using incredibly granular learning analytics.
So they're monitoring everything.
They monitor keystrokes, hesitation times, error patterns.
So the algorithm is handling the rote repetition, is handling the infinite patience required to teach a student how to balance a chemical equation 50 times in a row until they finally get it right.
Exactly. And by offloading that specific cognitive and administrative burden to the machine, it frees the human teacher to do what algorithms are fundamentally incapable of doing.
Yes.
An algorithm cannot inspire a disenfranchised student. It cannot motivate a child experiencing grief. It cannot contextualize a historical event within the moral framework of the local community. It cannot guide emotional development.
Wow.
The teacher is not an IT manager. They are the master architect of the human experience occurring within that room.
The master architect is a beautiful vision, but pedagogical theory can sometimes feel incredibly detached from the messy reality of a Tuesday morning in an underfunded public school.
That is very true.
To truly understand this architectural shift, we need to look at how this is actually playing out on the ground. And the source material provides 3 deeply illuminating global case studies that show AI actively breaking down immense barriers to learning.
These 3 case studies are selected perfectly because they apply artificial intelligence to vastly different domains: sensory processing, cognitive pacing, and physiological capability.
Let's examine case study 1, which focuses on a tool called LPC. The challenge here was profound and historic. Visually impaired students have always faced immense friction in traditional education settings.
Right, struggling with physical spatial navigation and accessing standard printed educational materials.
Exactly. The solution deployed was this AI-powered application that leverages advanced computer vision and machine learning algorithms. A visually impaired student can point their smartphone or a wearable camera at their environment.
And then what happens?
The AI ingests those pixels, processes the visual field, and translates it into semantic audio space in real time. It recognizes and audibly narrates objects in the hallway. It reads complex textbook layouts of paper, and it describes the visual elements of a science experiment as it happens.
The impact detailed in the study is just staggering. And it wasn't just about marginally higher test scores because they could access the reading material faster. The profound impact was a massive increase in the students' physical independence and psychological confidence. It completely transformed their ability to engage not just in academic tasks, but in the chaotic social environment of a school hallway or a cafeteria.
The AI acted as a sensory bridge, allowing them to participate in the shared human experience of the school fully.
Notice the dynamic there. The artificial intelligence isn't replacing human connection. It is actively enabling it by removing a sensory barrier.
That's a great way to put it. Now let's pivot to case study 2, which takes us to Newtown High School in Australia.
Oh, yes.
They're facing a challenge that almost every public educator on earth will recognize: massive heterogeneous class sizes.
It's the universal struggle.
Right. When you have 30 teenagers in a single math class, their comprehension levels are wildly different. A teacher is forced to teach to the statistical middle.
Which serves no one perfectly.
Exactly. The 5 kids who are mathematically gifted are profoundly bored, and the 5 kids who missed the foundational concept 3 weeks ago are entirely lost. A single human being cannot simultaneously deliver 30 different math lectures.
It's logistically impossible. So the school implemented a solution, an AI-driven platform called Math Pathway.
Okay, math pathway.
This is where we see the intelligent learning tutor concept in action. This tool completely personalized the math curriculum based on every single student's individual pace, historical performance, and specific learning style.
So it's constantly adjusting.
Yes, the platform continuously assesses their progress at a granular level, providing real-time feedback and dynamically adjusting the difficulty of the next problem based on how quickly they solve the last one.
And the quantitative impact is clear. Significant improvement in overall math performance, much higher daily engagement, and demonstrably better test scores. But the qualitative impact on the teacher's day is the real story here.
This is the best part.
Because the AI was silently handling pacing and rote grading for all 30 kids, it generated real-time diagnostic data. The teacher could look at their tablet and see a red flag indicating that exactly 3 students, let's say Sarah, John, and David, were completely stuck on the concept of dividing fractions. Right? The teacher could then pull those 3 specific kids aside for physical table and stage a highly effective, deeply targeted human-to-human intervention.
The AI handled scale, the teacher handled conceptual block.
Exactly. It's the ultimate manifestation of blend learning. Technology clears the brush so the human.
I love that. And case study 3 takes this concept into a domain most people would never associate with artificial intelligence. Physical education.
This one's wild.
Takes us to Sun Valley Primary in South Africa.
I found this case study utterly fascinating because it addresses the trauma of traditional gym class.
Trauma is real.
Right. The challenge identified was that traditional physical education grading rubrics rely on standardized comparative metrics. Blow a whistle, and every kid has to run a mile.
Right.
The natural athletes run ahead and get an A. The kids who are asthmatic or overweight or simply haven't developed those appropriate pathways struggle at the back. They feel public shame, and they develop a lifelong aversion to physical exercise. The traditional system does not meet the very physiological realities of students.
It's a one-size-fits-all model that fits almost everyone.
Exactly. So to solve this, Sun Valley Primary implemented an entirely different paradigm. They utilized wearable devices, fitness trackers. They continuously collected objective physiological data from each student.
Like what kind of data?
Resting heart rate, active heart rate zones, VO2 max estimates. They fed all this data into an AI system. The AI then generated highly customized, entirely individualized workout plans and cardiovascular goals for every single child based entirely on their own current physiological baseline.
The psychological impact shifts immense. The AI removed the comparative friction.
Yes.
A student wasn't being graded on whether they could be the fastest kid in the class. They were being graded on whether they could slightly improve their own cardiovascular output compared to last week.
Because the fitness plans were personalized, meaning they were challenging but physiologically achievable for that specific child. Their motivation and active participation skyrocketed.
And just like a math teacher in Australia, the PE teachers in South Africa could monitor small sounds and approach them to provide empathetic encouragement and coaching based on actual objective physiological reality, rather than just yelling at them to run faster.
Run faster.
Right.
It doesn't work if the heart rate is already maxed out.
Exactly.
If we synthesize these three vastly different environments, a visually impaired student navigating a crowded physical hallway, a dense Australian math classroom, and a sunny South African athletic field, a profound hidden pattern really emerges.
What's the pattern?
In every single case, the artificial intelligence is being used not to replace the human experience, but to surgically remove friction.
Yes.
It removes the friction of unreadable text. It removes the friction of a monolithic math curriculum moving too fast. It removes the friction of a standardized physical expectation that changes a child's body. It clears the path of all that unnecessary resistance so the student can actually engage deeply with the authentic act of learning.
It is a radical reframing of what technology is supposed to do. Now, these case studies showcase institutional power, right? Schools rolling out massive software platforms and wearable hardware.
Like multi-million-dollar budgets.
Exactly. But the beauty of the current technological moment is that the source material also provides a direct, highly practical playbook for how anyone, any individual learner sitting at home with a laptop can harness this exact same power themselves.
We are moving from macro to the micro here. The presentation outlines incredibly detailed, 8-step, hands-on activity for creating a personalized learning pathway using a standard AI chatbot.
And this is essentially a masterclass content.
It really is. It's brilliant because it forces the user to stop treating the AI like magic email or simple search engine and start treating it like a highly structured bespoke curriculum design.
Let's walk through these 8 steps because they are immediately actionable for anyone listening right now.
Okay,
The first step is to define your learning goal, but it must be intensely specific. You cannot just type teach me about human heart.
why not?
Because the latent space of the AI is too fast. If you generic garbage, you must narrow the parameters. Specific goal is improve my diagnostic reasoning skills in cardiology.
Okay, so specific goal. Step 2, identify your current knowledge. You have to be brutally honest with the machine about your gaps.
Right.
You would say, I have a basic foundational understanding of cardiac anatomy, but I completely struggle with interpreting complex ECG readouts. You're basically setting the floor of the curriculum.
Exactly. Step 3, specify your learning preference. How does your specific brain absorb information best? You need narrative structure, visual aids, hard data.
You tell the AI, I prefer interactive case-based learning scenarios that rely heavily on visual aids like diagrams and charts.
Step 4, set time frame and availability. This is where you introduce critical constraints. Algorithms thrive on constraints.
You need examples.
I want to prepare for a clinical exam that is exactly 6 weeks away. I can only dedicate 2 hours daily to this specific topic. We're forcing the AI to calculate the easy needs.
I love that. Step 5, choose assessment methods. How will you prove to yourself that you have actually learned the material? You have to demand friction here. I want you to generate rigorous weekly quizzes on ECG interpretations and grade my answers.
Step 6, request additional resources. You don't want the AI hallucinating facts from random internet forums, so you fence it in with authority.
Little information directly from Harrison's Principles of Internal Medicine and highly reputable peer-reviewed online tutorials.
Exactly. Step 7, define challenges and narratives. Now, this step is a stroke of genius. You explicitly tell the AI what is going to stop you from succeeding.
Likewise,
I have very limited access to high-speed internet during my study hours, so I need you to prioritize and generate offline resources and text summaries I can download.
that is so smart. And finally, step 8, customize and generate pathway. You take all those carefully considered parameters and combine them into one master prompt.
And the source material provides the final example prompt that a medical student would synthesize from those steps. It reads like a legal contract with a machine.
Here, read the prompt.
It goes, I am a medical student with basic knowledge of cardiac anatomy and physiology, but I struggle with ECG interpretation. My goal is to improve my diagnostic reasoning skills in cardiology within 6 weeks for an upcoming clinical exam. I can dedicate 2 hours daily, and I prefer case-based learning and visual aids. Include weekly quizzes on ECG interpretation, case-based discussions, and resources like Harrison's Principles of Internal Medicine and online tutorials. Also, I have limited internet access, so suggest offline resources where possible. Generate a personalized learning pathway.
Why is that prompt so effective? Because it is incredibly dense with constraints. It completely eliminates the AI's tendency to guess or hallucinate.
Absolutely.
It establishes a baseline, a hard deadline, a daily time budget, a preferred pedagogical style, specific assessment requests, authoritative source material boundaries, and it even accounts for the physical infrastructure limitations of the student's environment. It treats the AI exactly like you would treat a highly structured, very expensive human administrative assistant who is organizing your life.
And formulating a prompt that density requires the exact digital literacies we spent so much time discussing earlier.
The EFT concept.
Right. You have to understand how the machine parses information, how it narrows its probability distribution based on tokens you provided. The presentation also mentions tools like Notebook LM, which is an AI-powered platform designed specifically to help users synthesize complex information from a closed universe of sources that the user actually uploads.
So it only looks what you give it.
Exactly. But to use a tool like Notebook LM effectively, you cannot just be a passive consumer. You have to possess the literacy to ask the right questions and set the precise parameters exactly as this 8-step process teaches.
I want you to actively think about how you can use this 8-step framework in your own life the second this deep dive is over. Even if you aren't medical students studying ECGs, you can use this exact same structure to learn a new coding language like Python, to prep for a massive high-stakes presentation at your corporate job, or even to learn the fundamentals of architectural history before a trip to Rome.
You just swap out variables.
Exactly. It is entirely about taking active, intentional agency over the algorithm, rather than letting the algorithm direct you.
Agency is the operative word here. But as we step back and look at how intensely capable these systems have become, from instantly generating customized, highly effective 6-week medical curriculums, to analyzing physiological data to coach a gym class, to literally marrying the physical world with blind, we are inevitably left staring at the ultimate existential elephant in the room.
Yeah, we are.
And the presentation tackles this anxiety head on in its final section.
We have to address the direct question that the text asks. It is the question that every educator, every parent, and frankly every professional whose job involves synthesizing information is quietly whispering. Will AI eventually replace teachers?
The definitive answer provided from the source material, citing extensive educational research by John Madden in 2023, is a resounding scientific scientifically backed. No, artificial intelligence will not replace human teachers. And the reasoning goes straight to the core of neurobiology and sociology. While AI can process massive data sets at incomprehensible speeds, it cannot experience or project emotional intelligence. It cannot manifest genuine, spontaneous human creativity. It cannot replicate the deeply complex biological phenomenon of genuine personal interaction.
The source explicitly states that human teachers nurture empathy. They model critical thinking through their own visible struggle with complex ideas, and they foster personal growth through relationship building. The text explicitly labels these as irreplaceable qualities.
Because they are. You simply cannot code genuine empathy into an algorithm.
You can code the simulation without feature.
Right, but humans possess mirror neurons. We biologically know the difference between a simulation and the real thing. You cannot algorithmically generate the profound neurochemical feelings student experiences when a human teacher, someone they actually respect, looks them directly in the eye, recognizes their trouble, and says, "I believe in you, and I see how hard you are trying."
Wow. Yeah, if we tie this all the way back to the very first segment of our deep dive today, the UNESCO report and its 4 pillars of learning from 1996. Artificial intelligence is becoming unfathomably proficient at helping us learn to know by organizing the world's data, and learn to do by simulating tasks and generating code. It can curate the facts and it can simulate the friction.
But it is fundamentally walled off from the other two pillars.
Exactly. Only human beings can guide other human beings in learning to live together and learning to be. Those are distinctly, exclusively human endeavors that require the messy, beautiful reality of an actual human community.
So the irony is, if the AI is handling the work with, it is generating the massive data analytics on student performance. If it is managing the individualized lessons,
What happened?
it doesn't diminish the human teacher at all. It actually forces the teacher to be more.
That's incredible.
It systematically strips away the administrative robotic tasks that industrial era education systems use to force humans to do, like grading 50 identical multiple choice tests on a Sunday night.
Oh, the worst.
Right. It strips the robotic work away, leaving only the uniquely human, deeply connected, empathetic work behind. Clears the deck for actual mentorship.
That is the ultimate profound promise of this technological integration. It is not a replacement of the human spirit. It is a radical elevation of the human role in the developmental process.
Absolutely.
This has been an incredibly deep and rewarding journey. We started with Aristotle's ancient enduring wisdom that we must learn by doing. And we examined the very real cognitive dangers of letting machines do the friction-filled work for us.
The cognitive exoskeleton.
Right. We thoroughly explored the SAM model and Bloom's digital taxonomy to understand how to rigorously measure whether our technology is really substituting old habits or actively redefining the architecture of learning.
Driving the car instead of just having a big engine.
Exactly. We systematically shattered the pervasive myth of the digital native, realizing that true technological fluency requires deep, intentional, philosophical AI literacy.
EU did come 2.2.
Traveled to see inspiring global case studies where AI is actively removing friction for students from Australia to South Africa. And we learned how to masterfully prompt our own personalized, algorithmically driven learning pathways, all while continuously reinforcing the beautiful, irreplaceable humanist art of education.
It is a massive amount of conceptual material we covered, and it all points to one singular necessity. Intentional, thoughtful pedagogy must always take precedence over chasing the novelty of the newest software.
Pedagogy first.
Always. Whether you are an educator designing a syllabus for a university, a parent navigating a child's homework routine, or just a lifelong learner managing your own intellectual curiosity, understanding the structural pedagogy behind the AI prevents you from being seduced by empty technological garbage.
And before we leave you today, I want to share one final, absolutely fascinating detail that was quietly, almost invisibly buried at the very end of Dr. Junaid's source document.
I love this.
The very last slide of his presentation contains a tiny, easily missed note that reads, P.S. All the images used in this presentation are AI generated.
It's a brilliant, highly provocative twist.
It really is.
If a presentation painstakingly designed to teach us about authentic, human-centered learning, cognitive friction, and the irreplaceability of human soul is entirely visualized by artificial intelligence, where exactly do we draw the line between our own authentic creation and the tools we use to express it?
That's the million-dollar question.
The next time you sit down to create a product, whether it's writing an email, building a corporate presentation, or outlining an essay, look down at your hands, hovering over the keyboard, and ask yourself a very hard question.
Did you do the learning or did the machine? Remember that cognitive exercise. And we can help you build the future. You are the one who has to decide where you are actually wanting. Keep your hands on the controls. Thanks for joining us on this deep dive.